is, just go to Google and do a network speed test. And then you can, pretty quickly figure out if you're getting, over 100, I guess this is 100 megabits per second, which actually seems slow to me. I was expecting closer, I was in the hundreds, not a single hundred. That's weird that the upload speed is faster than the download speed. Okay, I'm going to look at my computer at work. And then I have this other computer where when I finished it, I was like, wow, to Ali, this computer can download way quicker. Whoops. It's expired. Oh my gosh. Huh. My password is expired. Okay, that's unfortunate for today. But yeah, on that computer, it has much higher network speed and was able to download the files faster. So yeah, if you're on a slow network, this may just be something that's getting that much data may not work out. So that is a good point. So yeah, if you're seeing super slow response, that would be the reason. Okay, so still we got about 85 people willing to answer questions this morning. Okay, I want to get a sense for those of you who were here yesterday, following along, trying to follow along, how did we do in terms of pace? Were we just losing you, or it was just a ton of stuff. So certainly the people who were not able to create the template document yesterday felt a little lost. And again, for the people who are just ranked beginners, we would normally front load a whole set of sessions to acquaint you with Skyline before throwing this much at you. But it's great that actually the winning thing is just right. We did Skyline Online, and actually I think a little too fast won. So I've tried to slow down a little bit. But yeah, it's fairly normal for the vast majority of people during these sessions to feel like, oh, this is either just right or a little too fast. And we really try to stay away from, wow, way too fast, or, oh, this is kind of slow. All right, so I think that's a pretty good distribution, actually. I'm pretty happy with that on the pacing and how everybody's feeling. I really think we have about 80 people who are actually following along this morning. And then, all right, so then here, free response. What did you find most helpful yesterday? So you're in your own words, just throw some things up there and we'll see what people felt like they learned. Yeah, Skyline batch processing, Q&A. Lindsay, she wasn't even here yesterday, but she was here on Monday. But Mud, she's pretty great for sure. Instructions, Skyline badge. This is great. There's some stuff about having the written instructions and the PDF instructions. And so we're going to quickly create the batch configurations today, but also Ali is working on getting written instructions up for that, so that people, if you fall behind or anything and you want to get caught up, there'll be written instructions for everything, so you can go back and redo it, and you make mistakes. And obviously these things are getting recorded too, and so there's going to be video that you can watch. And we really do hope that you'll take the time to work through these examples. All right, so let's go on to the next page. And then what do you most hope to learn today? This is the last question for you. And just, free response. Okay, well, that's coming. R beginner and MS stats. Okay, we can take a little bit of look at some of the plots and things, but the real delving into MS stats is going to happen next week. So hopefully people who are more interested in MS stats will stick around or come back on May 11th. All right. Well, thanks, everybody. These are great responses. Panorama features. All right. More devils and Scully badge process. All right. Well, that's good. We're gonna cut back over to the presentation slides for today to orient us on what we are going to do more hands-on. That was, somebody said they wanted more hands-on, and you're definitely going to get that. So moving on from Panorama, which we'll come back and look at some things on Panorama, not necessarily go through how to upload stuff ourselves. There's quite a lot of written documentation on Panorama as well, and some of the Skyline webinars cover Panorama topics also. So,
Brendan,
yes,
you are the host now, so you can use also the polling.
I can use the polling. Okay, great. Yeah, I have one poll, which is just to ask you whether you're with me, and or should I continue or not. And so, mostly I'm going to poll through the Slido interface we've been using, and thanks to everybody who has been using it. And okay, so let's move on. So yesterday we covered this idea of a two-phase experiment. I felt really introduced, to me in this Bruder paper, MCP 2015, and it was, what was done was to take one pooled sample from the set of quantitative samples and then multiply it and run DDA, like no fractionation. This is just replicate analysis of the same sample. And they took DDA samples and then they built a library out of that, and then they went back to their quantitative samples. And so today, published in the same year, is this Selevsek experiment, actually in MCP 2015. I did a bit of a double take yesterday, just remembering that it was the same year, same journal. The Selevsek experiment, what they did was they pooled and then they did chemical fractionation into, I think, like 42 different files, 42 different runs on a mass spectrometer, under the idea that, well, okay, we may not be able to see something in our pooled sample with DDA, because DDA is this semi-random thing, and so we might be missing low abundance things that we could see with a targeted method, that we can't see with just repetitive DDA runs. So they did this deep fractionation to get sort of a broader set of everything we could hope to see with a DIA run in these quantitative samples. And so so that's, I mean, it's similar, but the library is much broader, right? The intent of the library here, and in terms of Bayesian statistics, your priors, what you know about what you're searching for, is also different, right? So in this case, our prior is that, wow, we, without any change to the sample, we were able to detect this with DDA, which sort of says something about how detectable it is in a mass spectrometer and how abundant it's going to be in these quantitative samples, because this is exactly the same sample, we're just running DDA on it. Whereas here, our prior is weaker. We have, we now have we have information. We believe that that we can see it on a mass spectrometer if we fractionate and make sure that it's a high abundance thing. There are also papers published about how these largely fractionated, um, you know, large scale fractionation up to the point of doing 40 runs on the same sample fractionated has real problems with error rates. So if you're not really careful, the false discovery rate in this library is going to be considerably higher than in this library, and there's papers about that you can read. But anyway, so still very interesting experiment, and this is a beautiful data set, and I'm glad that they, in both cases they did such a good job of publishing these data sets to Peptide Atlas and Pride. So I sat down, read the manuscripts, and downloaded all the data, and then created these instructional data sets that we're working on here. And so this is the second one, but I wanted to highlight some things in the manuscript that were sort of important to me. And so the first one is that they did semi-tryptic digests. So not the last case we had fully tryptic peptides. In this case, the library or the search results, it's not that they did semi-tryptic digests on the sample, they use a semi-tryptic digest on the search, which means that instead of only looking for things that were fully tryptic, they look for things where they had a tryptic end, and then maybe something happened and the peptide got broken somehow after digestion. And so they're looking for things that just have a single tryptic end, and then that's the search space is much larger. But one of the co-authors, Ludovic Gillet, who I talked to, was pretty adamant that they get 20% more peptide spectrum matches, but he believes that they're real. They're not. It's not 20% false discovery rate with semi-tryptic matches. So you can use a semi-tryptic search in two ways. One, you can use it to expand your search space and then throw out everything that's semi-tryptic and say, I'm still sticking with only tryptic things. And that will actually lower your false discovery rate. If you keep the semi-tryptic things, then there's the question of are those real? And Ludovic, felt pretty confident that they were real. And then they allowed up to 2 miscleavages, which is just important. We're going to use it as a setting when we set this up. Carbamide methylation, you need to know, and then so carbamide methylation on cysteine as a fixed modification, and then oxidation as a variable modification on methionine. I should have highlighted methionine. So we're gonna, again, yesterday we had to make sure we had the right modifications. As you're reading this text, you have to figure out what are the modifications I want. Then it is useful to know that they did the search with both Sequest and Mascot, and then used this tool iProfit to produce a PepXML that had the results of both. And then I found this pretty questionable. Actually, they used a tool to calculate at what iProfit probability they would have 1% FDR. And they felt that the iProfit probability would be 0.02. And what that means, the iProfit probability is a posterior error probability. So that means any spectrum that I take with a 0.02 score, iProfit is saying, yeah, 98 out of 100 of those are going to be false. So it's just it means that your search results are really good, but to get up to 1% FDR, you're throwing in stuff that's almost surely false. 98 out of 100 are false. Only 2 out of 100 are true, but we're going to keep shoveling stuff in until we get to 1% FDR. And that's going to make your that's going to make your counts higher, but I would really say if you have a posterior error probability, pick something reasonable as a cutoff. And so we're going to use 0.9, which would mean that in terms of posterior error probability, that means 1 in 10 is going to be a false discovery. So I think that's a fine cutoff. So you pay some attention. Don't just take a whole bunch of false hits to get your FDR up to 1%. But I think, and then PSM level is a less strict false discovery rate. You're going to get higher false discoveries, and actually PSM level, especially when you're doing 40 runs, is dangerous because your actual PSM level for what you're interested in is the peptides. And if your FDR level at the PSM level, you're going to get more hits of things that are truly there. So I came away from reading this sentence with a pretty deep foreboding about the false discovery rate in the library if it were built that way. But luckily, and all I had was the library. But luckily, I was able to contact Ludovic and Natalie and get the raw data. And so we're going to build our own library here, and we're going to choose a different cutoff. And then on the assay library, so they then generated an assay library like the one we saw yesterday, and we're not going to look at that. We're going to create our own library. But just what that library was they took just the top 3 or 4 most intense single or doubly charged Y and B fragment ions. That's currently seen as too few. Most people would do 4 as a minimum, and ideally use 6 if you're going to run the kind of statistics that we're going to run. And then, so this is how many transitions. They got 83,000 precursors. And then that was, so yesterday we saw we had multiple charge states of each peptide. Again, they got 66,000 unique modified peptides. And so my feeling is that this is, a number of these steps are really tailored to make these numbers really big. We're going to look at today, how good is it to make your, what's the difference between making your numbers really big and just running everything through, and then going to a tool like MS Stats and saying okay, you tell me what's different. And so my assertion is that ends up giving MS Stats really noisy data. And statistics are meant to find signal in noise, but the noisier the data, the more difficult the job they have, and the less likely they are to come out with something useful for you. So again, just reviewing quickly what we're going to be looking at now a little bit. We're going to a little bit more of this targeted method refinement cycle. We're actually going to look at the Slevsec data and go through a refinement, and then we're going to eventually next week we'll compare what was the statistical impact of doing some refinement versus just passing everything we could possibly hope for through to MS Stats. So again, refinement is building a method, running the method, evaluating the results, refining, and then going back. And so it turns out that Natalie and Ludovic collected 2 data sets, and so they actually have two experiments. So we're able to do some sort of refinement and then go back and apply it to this next method. We don't actually have to do it sequentially. We have the 2 data sets, they've already done it, and so I was able to do I guess it's kind of a repeatability refinement. So it's based on, so it's basically a repeatability experiment and looking at the coefficients of variation of the peptides. So that's it for slides for today. Get rid of that too. And now we're going to, I guess, for people who weren't here yesterday, or there were some people who answered. I couldn't actually create the template file. I got stuck yesterday. I'm gonna just make sure that people are caught up. So I'm switching to my work computer, which I showed you before. That was its network speed, which was surprisingly slow to me actually. And here is my completed run on Skyline Batch. And then if you weren't here yesterday, what we're working on is this is my folder. So hopefully, if you weren't here yesterday, hopefully you've read enough to realize that you should have downloaded this NEU21 skyline.zip to be working on this, to be working on these data sets today. And then what we did at the start of yesterday was to say, extract the files and then just delete this and extract them right here. And that should go pretty quickly. So I'll leave that up for a second. I guess actually people can do extract all in Windows. So I was using 7-zip there, which requires a separate install. But if you don't have it, you can certainly do it in Windows. And again, just say extract all. You want to extract right into test. And that should go very quickly. And then you should have this NEU 21_Skyline folder, which is where we're doing our work. And then this is something I created yesterday, which we're going to leave for later. So your folder should look pretty much like this. These are the two data set folders, the Bruder and Celebsec, and this scripts folder contains the R scripts that we've used or are going to use. And then the reports folder contains this one file that we opened up yesterday to get some annotations and reports. And then here is the Bruder folder. Since I have, I've created this template and everything, so it's there, but there's actually a copy of the template right here. And so if you didn't manage to create the template and you want to sort of be caught up with everybody in terms of the template, you can simply, again, right click on it, extract all, delete the folder so it just extracts it right into this folder. And then if I do that, it's going to give me a bunch of warnings about overwriting things. But if you don't have the Bruder template file, that's a way to get it. Obviously then, and if you missed yesterday also, there's full documentation on how to do this, how to build your own here. So you could come back and do that. Just open up this Word doc. But today we are going, well, actually, so yeah, if I look at, this is my completed Bruder folder. If I look in here, here is Skyline and this skid. This is all the MS stats. So we could, here's a comparison plot. These are very large PDF files, but MS stats has given us summary plots for each of the proteins. So that's, and then, so we have a bunch of different plots, and we're gonna go over those next week. But we also have, this is the report that Skyline exported for MS Stats. So we've done a lot of processing, and we've gotten data directly out of Skyline. But we also have, this is the fully processed Skyline file. So for those of you who have both, if you only have Skyline Daily installed, which is what we're using, you should be able to, if you got this far, right, the people who said, hey, I successfully ran everything, you would have a folder here. So this is the template file. This is a processing, right? You can you can do as many processings as, different ways of processing this as you can come up with Skyline Batch pretty easily. And you would just save them to different folders. You can create new configurations. And then, but this is, all the results of the processing are now in this folder. And I'm going to double click on this because I have Skyline Release installed. So you can see there's not the little red arrow in this, and this says Skyline instead of Skyline Daily. And it's telling me, hey, this is the format version of this is newer than 20.2. And I think Ali mentioned this yesterday. So this is Skyline itself complaining, I don't know how to open that. That's a really new document. So now for those of you that have this, yeah,
Brendan,
yeah.
Actually, if you use Skyline Batch to open that results document, it will open it in the correct version of Skyline.
Oh, that's even better. So I was about, so yeah, so Ali added all these nice little things, like actually the way an easier way to get to this folder for the processing is I could just click open folder if I'd done this, and boom, I'm right at that same folder we were looking at. And then open results file, and this is the open the template file. So we've created all these things at this point, and we now have really quick launch buttons that Ali has put in Skyline Batch. So if we wanted, let's actually look at the template file again, since some people weren't here yesterday. So we can quickly click that button, and it will open Skyline Daily. And here's our template, just the way we left it, no data at all. It's got a library and all of these proteins, and then we can see that it's got 175,000 transitions. So that's great. But what we're really interested in is looking at the results file. So click that button. And this will take a little bit longer to load because it's got fully loaded data, and there are like 24 files in this data set. So one thing I'll note is that the Skyline processing is really now scales very well with the size of the computer. This computer is a hex core i7. So if I look at the performance and then say logical processors, you can see that here I've got 12 logical processors, and that works really well for these panorama or for the Bruder data sets. Both data sets scale pretty well onto 6 processors. So I encourage you to actually, and then the memory is, I have 64 gigabytes of memory. So this is a pretty nice machine for doing this level of processing. It's pretty big files. So if you were on a 16 gigabyte i7 with 4 cores and 8 logical processors, then the processing would go quite a bit slower. All right, so here we are, a fully processed Skyline document. Yeah, so let's talk about this, but definitely before we get into CelebSec. So here you can see the chromatograms, and you can see the various files, and I think we talked a little bit about, there was somebody asked the question of like, do I need to look at every peak to process this? And all the way through all the processing, we did a workflow that somebody might do with OpenSwath or some other tool that's not as visual as Skyline, and we got all the way through. We ran MS Stats. The reports would be very similar to what you would get out of an OpenSwath, but the nice thing is that we ended up with an artifact where we can go back and look at everything and double check how confident we feel about these results. So yeah, this is the chromatogram level for showing you all of the IRT peptides that are, they should be lining up pretty similarly. You can see they're changing a little bit, but they have a very similar fingerprint. This is what was once in a presentation called the protein fingerprint. So each one of these proteins will have and so when I click on a protein, Skyline will show me all of the peptides for that protein, and usually they're pretty consistent, right? So if I go across these things, I can see that they're pretty consistent. Usually I also would like to look at more than one set of chromatograms at a time. So I'm going to view arrange graphs, and if I just went tiled, I could get them, but they would all be, and it's, they're plotted here 24. It'd be a little small. So what I'd rather do is go back to arrange graphs and grouped. When you get this many, you generally will want a group, and maybe we could say 8, and tiled, and we're going to put them in the order that they were in the document. And yeah, what do I actually want to do? I think 8. So I'm looking at the data and it's in triplicate. So I see R1, so sample 3, each set of samples has 3. So I think I want something more like 6. Maybe I'll go ahead and force them into a row. That's going to be too kind of thin, I think. I guess I'll just let them be tiled. So, and then I'll distribute them so that I'll get one, so that I should get this top row as a set of panes. And then I'll get the next set below, and so there we go. So we have sample 1 across the top. So I can get all the sample 1. These are all the sample 1s, and then I can click and get all the sample 2s. So now I'm looking at all the sample 1s and sample 2s. This drop down here is pretty useful. It gives me the full list of the 24 that I have, 3 times 8. And I've gotten to about here. I'm showing this. So you can see that this is bold. This is the active set of chromatograms. And then if I go 1, 2, 3, 4, 5, 6, that gives me now sample 3 and sample 4. So I can get, it's nice to be able to see more than one set of chromatograms. And then if we go back up to the IRTs, here they are, and you can get a sense of how similar they are. So some other views that we might really want to see, I'm going to give targets less space. I think I don't really need the library matchup very much at this point, so I'm gonna make that, I'm gonna window shade that by clicking this auto hide button. And that means that if I put my cursor over this little tab here, it'll slide out and I can see, I'm at the protein level, so I can't see any spectra. But if I go here and then look, that's the spectrum for this peptide. So then the next thing I want to do is go to view peak areas and do replicate comparison. I just do these things pretty much automatically for almost every data set. I like to have these views up, view retention times replicate comparison, and then I mostly just put them on the side, like one above the other. And that gives me a sense, and I guess I would stop. Maybe people can use the chat to answer these. And when I'm looking at data, I like to sort of think about what are my expectations. When I'm looking at something right now, it's like, okay, I've already said, hey, I'm expecting to see very similar fingerprints, a protein fingerprint in the chromatogram view. So when I look at all these 6 plots, to me, they all look very similar. I can definitely see that the elution order is pretty constant. But now I've got these 2 other plots, and I guess, yeah, my question would be like, okay, these are the IRT standards. It's a diagnosis kit that was injected into every sample, and so like, what are my expectations of the retention time replicate comparison plot? And if you have an idea about an expectation that you have, please go ahead and put it in the chat. Like what would you expect looking at the retention time replicate comparison for injected retention time standards? You know, we did 24 runs, and these are the retention time standards, and yeah, should be similar across replicates. Exactly. Like ideally, so sometimes I even think of what would I expect, and then what's the ideal thing that could, the best possible thing would be, wow, these things are just straight across, right? Like that would mean there was no chromatographic shift of any kind. And then, but really, I probably expect to see some variance, but I pretty much hope that they're gonna stay very similar. These little bars here represent, they actually have the width of the peak, so you get some sense of the width of the peak as if you're looking down on it. Another way to look at this plot would be to go and say value retention time, and then you get a line plot. And that, if things are jumping around, that can help you to go like, whoa, this maybe is not correctly integrated if suddenly brown jumps to the middle of the plot or something. So at least our expectations, yeah, pretty good on retention time. And then the other thing that we expect is, if things are moving, we expect them to be moving together. So we don't expect to see like, and that definitely holds, right? You look here and it's like, everything shifted a little bit later. Almost every point here is a little bit later than the rest of them. And you can, so when, this first run, maybe the column wasn't conditioned fully, everything came out a little bit later, and then it seems to shift pretty consistently to earlier for the rest of the time. Maybe there's a little bit of a drift toward earlier. That's pretty typical on chromatography. Another thing that we might want to do here is to right click and order by, oh, you can't see that. Right click, order by acquired time, because that was just the logical time. So it's actually really interesting to look at acquired time, because okay, we're in a statistics class. What do we like? The acquired time is super interesting thing. Once you get a data set you don't know anything about, like, what can we learn from acquired time? What like, if I'm here, you have the if I'm here, order by document, this is just like how I put these things into my document, which is a logical ordering with sample 1, sample 2, sample 3. What do I hope to see when I switch to acquired time? Right? Statistically. Because actually acquired time can be a acquisition order on a mass spectrometer can be a confounding variable if you don't do the right thing. So randomization, yeah, right on, exactly. We definitely we want to see some randomization. What's the other thing we want to see? We don't want to see, well, instrument drift is fine. We might see that, but that's not something we want to see. No batch effects, yeah, maybe, but like, in terms of how did the person who collected the samples order their data? What I'm going to learn when I do order is just, I'm going to learn how they ordered their data on the mass spectrometer. And hopefully you're like, oh, I hope they did randomization, and what else? Blocking. So we hope that they did blocking. And if you don't know what that means, well, they actually did do blocking. So and they did randomization. So this is a really nice data set. But I've done this order by acquired time and gone, oh, they didn't do randomization. It's like completely in this very specific order. So let's go back to order by acquired time. I think Olga actually, I don't know if I'm, outing her here, but I think she might have been a reviewer on this paper and insisted that they go back and do randomization. But yeah, you can see that they did blocking. So each one of these set of replicates is its own self-contained experiment. if we had a mass spectrometer problem out here, or in the middle, and then fixed it, we might lose a full set of data and have to go, oh, we only have duplicate instead of triplicate. But if we did everything, all the samples measured, the way we had them logically ordered, then we lose subjects. Something goes wrong, we start losing subjects, at least, which are actually way more valuable than the technical replicates, Olga will tell you. So when you do this kind of replicate experiment, you want to do a full replicate of each thing, and that is blocking. So it's one method of blocking. There are other things that Olga will talk about next week. Okay, so we have nice randomization. These are obviously differently ordered, and actually, maybe some of the, what I said, what I was probably wrong about the whole column conditioning thing, because that wasn't actually the acquisition order. So back here, I was like, well, this might have been the first run, but it wasn't actually the first run in time. It was just the first run in the way I had things ordered. So this is hugely helpful. All of these graphs are clickable. So yesterday I was telling you about the Google Maps analogy. I think that's where the Google Maps analogy is the most interesting. Is that I call it directed investigation. Like, if I gave you all this information in a set of PDFs, it would take you so long to get through some of the things that you can get through when you can just go like, I'm kind of interested in what happened here, and click on it. Okay, so let's go down to the peak area plot, and ideally, what would we hope of the peak area plot? What we said, boy, these are retention time standards, they're injected. We should really see, pretty nice straight lines here. And if we do see variance, we really expect the variance to be, for all the peptides to move in unison as they do right here, right? They're kind of shifting in the same direction, all of them. Okay, so what would we like to see when we go down here to this peak areas plot? Anyone? Use the chat. Yeah, hopefully very similar too. Exactly. I was stunned when I first looked at these data and went like, wow, look at this brown here, it's like all over the place. And then I went, okay, well, it is also provides the latest diluting retention time, and it's a retention time standard. So while I would love these to be really stable in terms of peak area, they don't seem to be, and I've looked at a number of samples, and I think this may be one of the peptides that jumps up and down the most. Some of them are pretty stable. It is kind of interesting that we see this hump repeated over and over again. Actually, let's see, what if we did, you can switch to log scale. I guess that really kind of, can we zoom in on this? I'm not sure we can. No, we can't. It unfortunately, it's forcing us to include 10 to the 0, which makes it hard to zoom in and see these things. So log scale is not particularly useful here, but it does give you that sense of there's this curve, and that's a mass spectrometer effect is some, that for some reason, and that might be repeated in our data. That's why we might want some form of new normalization, like a global standard or median normalization when we process these data, because one, there's way more variance in some of these peptides than we would expect from standards injected at a constant concentration. But even the ones that are pretty stable have this curve over the life of the experiments. So I always find it a little bit interesting. Before I go look at any of the other stuff, I find it interesting. Okay, well, these were supposed to be the IRT standards. They're really supposed to be fairly constant. let me have a look at them. And you can learn some interesting things from them. So here are other ones. You see again, very reproducible retention times. Where you see big jumps in retention times, you can wonder, well, are they really integrating the right peak? And you can get to that information pretty quickly. You know,
And then
yeah.
can I pitch in with some of the questions because
Okay, go ahead.
they're
Yeah.
relevant towards the IRT?
Yeah.
So there's this question says, can the IRT peak areas be used to normalize, let's say, the intensity of the other peptides?
They could be, yeah. So I'm going to say, boy, you really wouldn't. You would have to, like, I don't know what. I think actually, Biognosis has done recent things to improve the peak areas of the IRT standard. So you might have to go back. This is a pretty old experiment. So I think they may have noticed some of this variance too and improved how they're produced. So don't take the way they're performing in this particular experiment as indicative of how they are now 6 years later. But yeah, you want to have some sense, and it's worth doing like a prior experiment to say, yep, this particular peptide or these set of peptides respond very similarly to the rest of my experiment, so I'm going to normalize to them. And Skyline makes that you could choose a particular peptide and say, yep, boy, see this curvature, I think that just happens to all my peptides. And therefore I'm gonna make this set standard type. Oh, it's already, because it's already an IRT standard, it won't let me set. Wow, that is terrible. Okay. I think you would have to, I'm gonna have to look at that. You could set it, if you can set it, anything that you can set as a global standard can become your normalizer. And I'm not quite sure why we aren't allowing that to happen with so normally I would expect you could set a standard type to global standard. I would actually even also expect it to show me that the standard type was IRT. But anyway, so I guess my quick answer to that is like, wow, it really should be possible to do pretty easily. And there are definitely IRT standards where you might want to use them as your global standard as well. And that seems to be broken right now. So I'm going to go back and look at that. But to normalize, if you find something or you have some other injected, you might have some QC standards or some other standards that you want to label. And you can even do multiple selection, and then we can normalize everything to the sum of a set, or the average of a set of peptides. So you would do global standards. Surrogate standards, probably not for a massive document like this, but surrogate standards allow you to choose different standards for different peptides. So you might have like a standard that is for the early eluters and a standard that's for the late eluters. And so it's very flexible. I'm a little bit surprised at this moment that it's not allowing me to do the IRT standards. But you would definitely, you want to have some prior knowledge of your standards and make sure that you don't choose something that, wow, this is great for having the latest diluting, a stable latest diluting time in my retention times, but it's really not any good for using as a normalization standard. Okay, so any other questions that you want to throw in?
There are two, but they're like more on, there's a lot of steps that have been skipped before this. There's two questions. How do you load MS data into a Skyline document?
Okay, so yeah, if then you've missed Monday and you've missed Monday and Tuesday. So for that question, like, do a tutorial. That's all I can say. Yeah, yeah, that's a little bit too basic at this point. Anything else?
Not for now.
Okay, so yeah, so we can go and look, and some of these look like, wow, this is, you know, this is a pretty big changing. And if we I think if we go back to order by document, we can see, wow, this really looks to be something that's changing, you know, with these samples are I think they're a perturbation where so we're expecting some things to change, and this is very obviously a change. So let's see, we can also group by here condition, and that will give us fewer points, and it will give us these whiskers, and now we can start to see, oh yeah, like, you know, we can get some descriptive information about the kinds of things that we'll see in MS Stats when we come back to MS Stats. But we can start to get a descriptive sense. So, but before we go into and I'm actually not going to review this data very much. Hopefully you have done this experiment, and you know, if you didn't get all the way through this skyline batch, I encourage you to keep working on it. If you have to get to a computer, hopefully everybody has access to some computer with a pretty fast network. That's the only way you're going to get these files. There's just, you know, I'm happy that I was able to condense what you absolutely need down to about less than a gigabyte, but this is quite a number of gigabytes worth of data that get downloaded. Okay, so, but yeah, then you will have a document like this, and if you follow these steps, seems, you know, you create a template document, run Skyline batch, and then you didn't have to go, like, I could guide you through all the steps that that Skyline batch did for you, like go file, import, results is the way to get new results into a Skyline document. So we would go through all of that, and then refine, reintegrate is the way to create a scoring model. It's also a way to look at the scoring model. So we're definitely, I think I pointed out yesterday that you can find it in the log. So when we were looking at the log yesterday, Ali's log, this is all the import happening on this computer. You can see that it's doing 6 files at a time because it's got the hex core, and it gets through that fairly quickly. And eventually, here is the model. But that's, you know, so that's a summary on that. And if you learn how to read this, you know, you can see things like, wow, the model found over 500,000 peaks. Good, like that. And you can get some sense of, oh, okay, yep, it's got a library intensity dot product store. That's a really important score, and it's showing up as really important. The retention time difference, it's providing some weight, so it's doing something. So that's good too. The coelution count is usually a strong score, so it's a strong score. So those are, you know, some things I can check in here. But if I go to the Skyline UI, here is my peak scoring model, and I can just click. So I got here, for people who have this document open and are following along, I can go refine, reintegrate, and this is where I can create a new model, but it's also where I can click edit current, and Skyline will go back and recalculate all the component scores for the model. And then it's going to give me lots and lots more information than that summary that I found in the log. So despite that you can, you know, zip right through and actually have MS Stats results, you can come back in here and really assess your data and say, like, is this, you know, was this good? Did this work out okay? So here you can, you know, you can see that we chose to use decoys. The decoys are down. You can actually, if you see the status bar is still showing down at the lower right here, I'm circling it with my mouse. You can see that in this document, I have 350,000 transitions. Those are the decoy transitions. And so then here are the scores for the decoys are these orange scores, and for the targets are these blue scores. And we can see, you know, what we're looking for is we're expecting that under the decoys will be the false discoveries. So there is some sort of distribution here that's similar to this. It's just that the vast majority of things are separated and we believe are actually true hits. And that, you know, we have the prior experiment that was done here was to run DDA. So we're just finding that, like, boy, if we just ran a few runs of DDA on our sample, we're able to find the vast majority of those things with DIA2. That's what that tells us, and that's not such a radical thing. Once we introduce the fractionated library, we're going to see that we're going to start to get a bunch of things that we looked for that look a lot more similar to this decoy distribution. So yeah, so this again, this is the same weights and percentages that we saw before with library intensity dot products giving us a lot. We can drill down. Well, we can look at the p-value distribution where we're expecting the decoy p-value distribution to be very level. And then these are the p-values of the targets. And then this is how, you know, our q-values were distributed. And we can look at individual feature scores. So this is the intensity feature score. We can see, yeah, it probably provided some separation. So that's why it's getting a little bit of weight. And then we can just click on a row and see the retention time. You know, we can take a deeper look at that. Library intensity dot product. Okay, yeah, wow, that really does separate things. That's why it's so different. Shape score, also pretty good separation, but maybe similar to some other score. Coelution, and then coelution count is a very you know, this score doesn't have a lot of buckets, but it's clearly also doing a pretty good job at separating the decoys. And then signal to noise doesn't really do so much, and that's why it got set. And then this mass error actually, you know, the reason it's red is it went a little opposite of our expectations. So the weighting we would expect to be negative, right? So we would expect that you would get better mass errors for the targets than the decoys. And what we're seeing is that the decoys actually, or the targets are actually further away from zero than the decoys. So, okay, so this is also another important thing. So now we're going over things that you can do to sort of assess the health of the processing that Skyline Batch did, that Skyline did. One is to look at the model. You definitely want to be confident about that. If you're missing any scores, sometimes you might come up and do that reintegrate and find that some scores are grayed out, and then that requires investigation. There's a whole tutorial. That's explained in one of the tutorials. But let's go and look at the mass errors. So Skyline provides a histogram of mass errors. And so we can go and look at it and say, whoa, you know, like that is, you know, the mean is 5.9. So it's out by 6. That's actually a mean. So we see quite a bit of tailing here. Yeah, so that's pretty interesting distribution. One thing that we can do, it probably won't make that big a difference here, is to say targets at 1% FDR. So that just kind of, that didn't actually change the distribution much. The points, what we can choose what transition we want to use, either the best, or we could say all. We don't have any precursors, so that wouldn't work. But this is, okay, so now this gives us, if we did best transitions, we're just using 1 per precursor. So we got 58,000 points now. 1,000 points. It doesn't change the things very much. We have this mean of 5.9, standard deviation of 3.8. So, and then what I would tell you as a rule of thumb, when you look at this, you're asking yourself, did I use, you know, or one question you should be asking is, did I mess up and use too tight a window when I set up my settings? So transition settings, full scan, I said 15 ppm mass accuracy. If I use something too tight, that would be a problem. And so in this case, like, or what I use as a rule of thumb is, so this is basically 6, and then I multiply this number by 3. So that would be, 11-ish. So 6 plus 11, I would say, yeah, you should probably use a 17 ppm. So maybe this 15 ppm is a little bit too tight, and I should maybe use 20 ppm or 17 ppm, but it's not way off. So there might actually be more tailing out here than we're capturing, although it does kind of just come right down. But so we're not way off. If you saw something that looked like a Gaussian that was cut off by the histogram, then you really feel like you were way off. So like if we had chosen, say, 10 ppm, right, we would, you can imagine that if I had done 10 ppm, I would have a very steep drop off on the right side. So here we can wish that, Skyline, I promise in the future, will have the ability to, and hopefully automatically do it itself, adjust the mass error to this mean value, so that this explains why the score wasn't any good, is because all the good targets are centered around something that's not 0. So in order for it to be useful as a peak score, they really should be centered around 0. Another thing I can do is switch to the graph and look at a 2D histogram, and that can be interesting to decide, are there any other effects, like over retention time, is the mass error getting worse? Well, maybe there's a little bit of slope here. Sometimes it can be useful to do log scale. Whoa, and that just basically gives us, log scale makes things, the gradient less dramatic. But we can turn it off, and that gives us a pretty good sense. The other dimension that we might be interested in checking, there's nothing up here over the retention times. It's pretty stably the same distribution we were seeing, but we might want to change the x-axis to mass to charge, and that would tell us, yeah, there's not really any sort of curvature or anything here. Really, this mass spectrometer was just, poorly calibrated, off by about 6 ppm. So definitely interesting and useful information to always check that. The other thing that I would just almost always check, is the retention time. So we saw that we got we got better weight out of the retention times in our scoring than we got out of mass errors, but we still would want to go check regression, score to run. So this is testing the correlation between my IRT scores and the peaks that were actually chosen. And this is the linear regression. I can choose to switch to the points and just show me the standards. So this is where the standards are falling. They're quite linear. And I can switch to whether or not I want to show, this is using the averages of all replicates. Sometimes it can be very interesting to zoom in on a single replicate, or now the points will change slightly every time I choose a different replicate. So now let's go back to points, and we'll use the targets at 1% FDR, which is really most of the targets. And that's how, and we can see some jogging around and stuff. And so it's often very interesting to switch to a plot which is the residual plot. So that's just showing that. So yeah, wow, the chromatography of the system used to collect the IRTs is clearly pretty different from the chromatography of the system used to collect the DIA. But this speaks to the question yesterday. Somebody asked, well, what if I have a nonlinear gradient? Well, this is certainly, there's a nonlinear relationship between the chromatography of the system that scored these IRTs and the system that collected the DIA data. And yet, we feel pretty good. There's not really much butting up, we don't see, we've given it 5 minutes on either side. So this is basically the range that we allowed it to choose right here. 5 minutes, and we're not seeing very much that comes all the way out to that 5 minutes. So we still get the majority of our data within 2 minutes of our predictions, 3 minutes of our predictions. So retention time prediction is still pretty good and useful. And it's not strictly linear, but we use the linear regression to get there. We can also switch to, okay, so what do the decoys look like? So you frequently, and they're spread all over the place, right? So there is some density in the middle here, and that's maybe to be expected because of the fact that we gave it some weight in our scoring. So we said, these are the peaks that as they were picked based on the score weighting that we came up with. So we're going to end up, but yeah, this is, so everything here looks really great. We should feel pretty good statistically about, how we process this data. And, that's the hope, since I came up with all the parameters before we started and guided you through them. But if you find issues when you're looking at this yourself, it may be a reason to switch your parameters.
Brendan, there's 2 questions that
Okay.
I would like to throw in because might be relevant. There was one question about retention prediction are based on which solid phase of liquid chromatography, C8, C18, something else.
C18. Yeah. So these are, these are C18. These are C18 based values. But yeah, if you were doing some other type of chromatography, then we don't necessarily expect these IRT values to work as well for you. And you would have, but Skyline totally provides the ability to calibrate them yourself. In this case, we have actually calibrated almost everything ourselves. And yeah, so there's a whole IRT tutorial on the Skyline website. As again, as I said yesterday, Skyline has a lot of tutorials. Let me just, and I, if you're new to Skyline, you really should do more work on these tutorials. And so here is I think advanced topics is an IRT tutorial. So hopefully this will launch you off into learning more. Okay. There was something else, Juan?
Yes, there's a question that says, can you look at mass error versus acquisition order? I guess it's on the lines to see drift in the calibration of the instrument as a QC
Yeah.
parameter.
So, okay. So not, yeah, there is not actually. So if we go back to mass errors view, if we go back to this plot, that's a kind of interesting, that's an interesting point. So mass errors, histogram. If you're looking at the histogram plots here, also we're now on replicate single. So you could, if you're interested, you could get a little movie of that by just going here, and yeah, like there does seem to be some mass error shifting by replicate, which maybe explains why it was so round. So this thing, when I did before I was on replicates all, and you can see it's really rounded, but yeah, thanks for pointing that out, whoever came up with this question. I'm going to close the retention time plots because it's doing a bunch of background processing while we're doing this. So yeah, frequently, yeah, and that happens also. I think that will happen in our next data set. You may see a really weird distribution, like maybe it's even two humps or something like that, and that can mean that something happened in the middle of your acquisition, and it can be very interesting to switch back to single. But we don't have, other than that, what I just showed you, sort of shifting through the replicates, we don't have a histogram way of looking at this over time. That would be kind of interesting to have, like, okay, what was the mean over time over your experiments? So you can see, yeah, it's shifting from quite a bit, actually. Oh, but so we're going through these things. Remember that we're going through these things in acquired order. Wow. But we can also bring up, so that, yeah, there's quite a bit of complexity here that I had never thought of until this person gave us that. So we can go to mass errors and go replicate comparison. And then if we select a specific thing, we can start to see the mass errors of that thing over time. Oh, actually, I want to group by replicate. So now we can see that over, for that thing over time, it's not, not super obvious that there's oh, wait, but we got to order by acquired time. And there we start to get at the question. The true question was, maybe there was drift. Yep, there was drift. It went all the way out to 10. So in the last replicate, we're pretty far off, which explains why, we start to actually even think that, hey, being far away from 0 might be a good thing, right? That's what when we looked at the score and it was like negative to our expectations, it's that, it might start to be a good thing. So this definitely is a case for calibrating the mass errors after import. So having Skyline say, like, hey, you know what, I can see this trend, and yeah, there you go. Over time, the mass error drifts quite a lot from being around 3 ppm off to being as much as 11 ppm off. Thanks for that question. Great question.
There's actually a follow-up question, which I was also wondering: can Skyline do recalibration based on peptide entities or something like that?
It can and it should, but it doesn't. So yeah, it's
Okay.
it's been on my list for years now. Like, that's the sad thing. We do things that are like, wow, that's been on the list for 8 years. That's one of the sad things about being on a project for 13 years, is you can look back and say, huh, yeah, we realized we needed that in year 2, and we just finally did it. So it's all a matter of prioritization and who we have doing the work. So certain developers really like working in certain areas, or it's definitely, you have better efficiency if you can give somebody like Brian Pratt and say, like, okay, you own ion mobility and small molecules, and you're going to spend a lot of time on those, and I'm not going to disturb you to throw in a feature for something else. So yeah, it's a live person management feature implementation problem. But yes, we recognize that recalibration would be useful, and it's on the list. So okay. So anyway, but yeah, you can get to, there's enough mass errors. All of these different things have various plots that you can look at, and mass errors can be pretty rich. And thanks for the questions to guide us to look at certain things. Okay, so then the last thing I'm going to look at here, I'm not actually, there's the question of, like, do I have to look at every peak? And I've said, no, you don't have to look at every peak. Look, we already got MS stats results out of this, and we haven't even looked at anything. And so I'm still focusing mostly at the statistical level. I'm showing you histograms. I'm showing you, this is all the statistics. If we went into every peptide and looked at every peak, we would see mispicked peaks. And this happens when people import, when people run OpenSwath and then they import their data into Skyline. Even we have a way that we can make it so that Skyline chooses exactly the same peak that OpenSwath chose, and people go like, it's making mistakes. And it's like, well, they're all making mistakes. It's just that we're going to treat that as noise. And if we've done things like randomization, everything, we can treat it as noise and use statistics to hopefully find signal in the noise. So the next thing I wanted to look at is this was actually put in the last release by Rita Chupalov, and this is detection. So now we can look at our another way of looking at the detections. This is a fairly common plot that was in a number of Aebersold Lab publications. Certainly the Pan-Human Library cross-site. I worked on that with Ben Collins quite a bit, and it became clear that this was a very interesting plot. And so this is showing us the detections in each run, and we can see, okay, this is the I think this is the median value this is just the value of things that were detected in at least 12 runs. So you can see it's a little bit higher. It's a little bit higher than all of the 24 runs, but not a lot higher. And we can see this curve. If this curve were just going up and up and up and up, that would mean that there's not a lot of overlap. There's a bunch of stuff in here that's just accumulating. And so if you see this cumulative score really taken off, that's indicative of a false discovery rate problem. So this, when we look at this, we go, yeah, probably not a false discovery rate problem. We're not finding a whole lot of new things. Of course, part of that is that we are finding almost everything that we're looking for. And then here is this drop off is what was actually visible in all runs. And as we add runs, that goes down. But still, about over 20,000 things we have a peak detection of every single one of those across all 24 runs. So that's pretty good. That's getting back to that heat map that we showed about missing values. The missing values here are pretty nice, and not that many of them. And then the other plot that you can now do with detections, if you go graph type, you can look at a histogram, and this is a pretty good histogram as well. We like to see that, again, most things were detected in all, by far 20,000 were detected in everything. And then we have still thousands of things that were detected in just 22, just 21. And, by the time we get out to the middle here, we seem to be losing a few hundred every time. And what we really don't want to see is another peak over here where it's like, wow, look at, if there were a really big set of things that were only seen in one run, then that would be indicative of false discovery rate accumulation. So that's how you use those graphs. And so that's all just statistical assessment that gives us some pretty good feeling of how this stuff was acquired and it's, and processed, and our settings were right, and we should feel pretty happy about this. And so we're going to put this data set aside and move on to the next data set, and then we'll come back and look at it again, maybe with MS Stats, and Mina can tell us how to analyze the MS Stats results. So if all we're doing is we want to get a first look at these data, we don't need to do any other looking, point by point of this stuff. We feel pretty good about how this was processed. So I'm done with that data set. I guess I just click new. We're going to start on a new document, but I want to take a break because we've been going for a while now. So let's take a 15-minute break and come back at 9:50 on my clock. I don't know where you are. So Pacific time, 9:50, we'll be back and we'll switch over to looking, to actually, we're going to build our template file for the CelebSec data. So we're going to switch from Bruder. We've done everything we want to do with Bruder. We're going to switch over to CelebSec, and yeah, that's coming up next. We'll be working in this folder in 15 minutes. And I'm going to step away. Thanks.
Brendan, can I ask you a question?
Yeah, sure.
Because it's a little bit of a follow-up on the recalibration. Because I think I remember once emailing with Matt about the possibility of recalibrating files with MS Convert with one of the filters, but it will require a peptide identification file like a MZID and the MS file. Can you confirm if this is possible?
Yeah, I'm not sure I would do. I mean, you can import. Yeah, I don't know. Like, yeah, I can't actually comment on whether that's possible. And really for these files, switching to MZML often would be very big.
No.
Like, so that would be a lot of work to recalibrate. Isn't it? It's too bad there's not some thermo raw file way of recalibrating. One time when I found a very we had this data set where Bruker came and said, "Oh, Skyline's not doing very well in this data set," and it turned out that it was this very strange mass calibration where it actually was curved. That's why we have the 2D plot where, so it was like on the low MZs, the mass error was quite a bit higher than the high MZs. And then they were like, "Whoops, we forgot to run this calibration tool," and they ran it, and then the data worked much better. So if you can actually recalibrate the data using a vendor tool, that definitely can be super helpful. Because then then it can stay sort of in place.
And another for the Waters instruments, it's implemented that you can do the log mass correction.
Yep.
For Bruker instruments, I remember there's a very specific way, but it requires them to kind of acquire a calibration scan before every LCMS run to do post-acquisition recalibration. But I'm not sure how SciEx instrument will deal with this, if possible at all, like the data from this tutorial.
Sorry, what was the question?
No. It's already answered. One of the last ones.
All right. And then lock mass correction got me to think of in our lab, we've just been told not to use lock mass correction on thermo instruments because scans where when the lock mass is not detected, rather than use so if you have scans where the lock mass is not detected, then they just switch to uncalibrated rather than using the last detection.
Okay.
So it's like, it's really I guess in a sense, I hate to say it right here, but in a sense, in saying that you just like with thermo, don't use lock mass calibration because it's implemented in such a way that it'll just give you more variance, and potentially quite. So if your lock mass calibration is shifting by 10 ppm, you're gonna get some scans that are gonna be shifted by 10 ppm and some that are not. Right. So you'll have this weird bimodal distribution. So our lab is definitely like turn off the lock mass calibration.
Thanks for that comment. I will have never thought about it.
But yeah, check it out yourself. If you have an instrument that's sort of out of normal calibration and you try lock mass, what I just heard at a McCoss lab meeting was that will cause some of your, like that when you do lock mass correction on a thermo instrument, it doesn't, it can be very inconsistent.
Okay.
I'm sure they've told thermo about this and it's going to be fixed, but it's something to be careful of for sure.
There was one last, since it's related, it just came in. It says for Bruker instruments, recalibration in the software just adds an additional calibration file. Does
Yeah,
Skyline
so
recognize that?
does Skyline recognize that? Well, Skyline doesn't recognize that, but the Bruker software does. So yeah, Bruker data files are a folder, and they add a calibration file into that folder, and then we use DLLs from Bruker to read that folder. So we don't ever go in. We never, like, even when vendors suggest, like, oh, you could get that information from that file in the folder, because about half the instrument vendors have a folder and half of them have a file format. Then we were like, oh, that's great. Can you give us a DLL that looks at that file for that answer? Because we don't want to write our own code, because they change things all the time. So, but yes, it does work. That's pretty much describing exactly the experience I had with Bruker, which was, they gave me a .d folder, and I eventually came back and said, this looks like really weird mass error. I'm getting really weird mass errors here. And they went, whoops, we just ran a calibration tool. Here's the .d folder again. And everything worked great. So, okay, so we're back to 9:50. Hopefully people are back at their seats. Can't see any of you, so I don't know for sure. But okay, so we're going to start working on this SelevSec data. I actually have opened this SelevSec data settings document. There's a PDF form, which I opened here. Whoops, yeah. So you can also get it's the Skyline instructions for day 2, but you don't need to do so if you have 2 monitors, I put it up on one monitor, and I'm gonna go through it, make sure that I don't make any mistakes, but you don't need to, but that's can be a nice way to go through this. So let's go back to this computer. Here we are. And we have a brand new document, and we're going to start by, again, asking for the default settings. We don't want to save our old settings, so we're going to get everybody back on the same page. One thing to be aware of is that everything we've done so far is getting captured in this audit log. So, and we just we just reset everything, and so we changed the settings, and so now we have a bunch of stuff in the audit log. But if we then click new again and say, no, I don't want to save change settings, now we're back to an empty audit log, because we have the default settings and we created a new document with the default settings. And so Skyline's like, well, okay, you've done nothing. So that, whereas if you created a new document without the default settings, then Skyline's going to say, like, okay, these are the changes you made relative to the default settings. So this, I should have showed this audit log yesterday when we finished creating our template. We'll come back to it today when we finish creating our template. But so right now, just to be aware of, if you want to get starting with an empty audit log, you should do both settings, default settings, to get that checked, make sure that that's checked now. And then after you do that, click new document again, and that will clear your audit log. All right, so I have to arrange things a bit better on my screen here. Okay, so so the first thing we're going to do with that empty file is to save it in the right place. So File, Save As, and you might come up in Bruder, which is where we were working before. That's how I came up. But I'm going to click up at the top here. I'm going to go to my NEU21 Skyline folder, and then into SelevSec. And then I'm just going to save it. This is my, going to be my new template, Selev sec. Yeah, just call it slevsec. Natalie's last name. So there we now have this empty slevsec.sky file. Not very interesting. It's got the default settings, but we're gonna launch from there. And I hope the next time I present this, I'm going to be able to say, oh, the next thing you should do is do file import peptide search. But again, it turned out that there are some settings that are not available in that wizard. So we're going to first prepare those settings, and then we'll go back and run the wizard. So there's a number of steps I'm going to have to do to kind of weave my way around some issues that we're going to fix in Skyline. And that's, one of the huge benefits of teaching Skyline so much is that it's a very high bar to create software that's easily teachable. And so every time we go out and teach it, we find new things that we should make easier and better. So peptide settings, I guess I came up on modifications. If you came up on well, we'll come back. Okay. We'll go to filter. And the first thing we're going to do is, to match more closely with what they did in the experiment. They are allowed minimum length 7. Last time, if you remember, we had 6, and maximum length 45. Last time was 55, and we're also not going to exclude any N-terminal amino acids. So these 3 controls are definitely going to show up in the wizard, but so far we've had to change them outside the wizard. And then, so hopefully everybody has, that's pretty simple, 7, 45, and 0. And then it is possible to set modifications in the wizard, but for some reason the wizard is not showing that page right now. So what we need to do is, I showed you on the PowerPoint slide that they did carbamide methylcysteine and oxidation on methionine. So we need to reflect that in our document as well. So that's what, you should have created that yesterday. Hope, I guess for anybody who wasn't here yesterday, if you're brand new to Skyline and all you have is carbamide methylcysteine here, you would go to edit list and then add, and then type OX and down arrow, or down arrow twice, but yeah, or you can find it in this list. But you want oxidation M, and I think if I say okay, it's going to say, well, you already have that, but that's the way you would add it, and then you would click OK, and then just make sure that those 2 things are checked in your document. So now that's all we needed to do. Those things are definitely going to be available in the wizard in the future. Now we're going to go to File, Import Peptide Search. And we're going to tell it that we're doing DIA. And then what we would next do is we would say the cutoff is 9. We're building from search results, and we want to do automatic IRT generation. And we're not going to include ambiguous matches. An ambiguous match, I guess if you hover over it, will it tell me? No. It should, I would like it. That's something we'll have to fix too. I think frequently when you hover over these things, you'll get some sort of tip. I don't know why it's not working. So an ambiguous match is when 2 peptides match the same spectrum. And since we're really trying to be pretty rigorous about about our information about retention times and the relative ion abundance, we want to make sure that the spectra are things that reflect a single peptide. And then we would add results files. And at this point, I think, I'm not even sure I have those files on this machine. I guess I could go, you don't have the files. We're not going to be able to build this right now. But I guess I have them down here in examples. I have it in here. No, not really. So here's this DDA folder. And so this is what you would ideally see. No, that's not even what you would see, I guess. Yeah, so this is the interact ipro.pepxml. So that would be, you would choose that thing, except that I call it iProfit combined. So I had a different data set on that one. But anyway, so we can't do that because you don't have these files. This is, again, this is gigabytes worth of data, and I chose not to have you download all that. And then it takes 27 minutes to do the build. So it's a pretty long build because it's a highly fractionated data set. So actually, instead, I'm going to have a video here. So this is me doing it last year. I recorded it. And so I'll just play that, and you can see what would happen next from this video. So now we've gone into fast mode where every second is a minute. So this is going to do 27 minutes, and you can see this progress. It's kind of getting grayed out, but you can see this is the progress of building the library, and you can see it's going through a number of MZXML files. So pepxml and MZXML processed with Mascot, Sequest, and iProfit. And so now we've actually finished all that processing, I think. So we're back to normal speed mode. So we just did about half a minute of, a minute per second, and now we're back to normal speed. And what it's doing is it's compressing all of the duplicate duplicate peptide spectrum matches into a non-redundant library. So it's done with that, and now it says, okay, here are all the ambiguous things. These are peptides that were multiple peptides assigned to the same spectrum, and I know that Mascot does that. I'm not sure whether the Sequest that was used does that, but we've just rejected all of those. And then now it's just doing the retention time processing to come up with a retention time calibration. So this is building the IRTs. These data, they did inject the IRT standards, but they forgot to search for them. So the search results didn't contain them. So I decided to go with a retention time calibration based on those conserved peptides. So they're not the standard peptides, but you can still create a retention time calibration with those. So the first time I processed it, I did some extra work to find the IRT standards and stay with the IRT standards, but later I realized that I could just use the endogenous peptides. And that's it. That's the processing to create this spectral library, which Skyline then saves as a file called .blib. And if we go to the SelevSec folder, I have left I have left this SelevSec 90, so that's how I express 0.9 blib. So this is the blib file that was created, and you just saw a video of how it was created. And so instead of building it yourself, which would take every one of us at least 27 minutes, we're going to switch to use an existing. So this wizard allows us to use an existing library, and then click browse and just choose this SelevSec 90 lib file, which should be in the same folder. You should be right there, and just choose it and click open and get to where now you have a spectral library. You didn't need to build it. It's just the one I gave you. But I can also make those files available. They're actually not up on the FTP site. I had to ask Ludovic and Natalie for them, but they sent me all those files, and I can make those available for anybody who, like, go ahead and chat me that you want those files if you want to go through this build from scratch. So let's go ahead and do next. So now it's just kind of building enough information that Skyline understands this library. This library match view just showed up, which tells you, oh, Skyline has a library in this document. And now we're going to, we're not going to import any results files. So normally if I'm doing all the processing through the UI, I could specify some results files, and but since we're going to use Skyline Batch, we're just creating a template. So we just skip right by this. And we get a message saying, you know, are you sure you want to continue? Continue will create a template document with no imported results. Well, that's exactly what we want. So we just say yes. Oh, I see what happened. Nightly test has started on my computer again. If you were here yesterday, you saw that happen as well. And I have to just quickly get rid of that. I should have disabled it yesterday. All right, so boy, what's going on? Where am I? Huh. Okay. Oh dear. I'm gonna go back to that. Shoot. I just canceled the wizard. I got confused. Let's see. I guess I will just. I'm gonna undo. Let me give me a second to catch up with you. File, import, peptide search, use existing. All right, so now I think I should be back to where, woo. Oh my gosh. Sorry. Okay, file, import, peptide search, DIA, use existing, browse this file. Okay, so now I should be able to click next. This is looking for results files, which are DIA files, and I can say, yes, I want to continue because so now we should be all on the same page again. Sorry for the strange digression. So let's all we need to do here is add 4. We're not going. Last time we did 1 through 7, and that was quite a bit of work to fill out. But we're just going to do 1 through 4, and we're not going to include precursors this time. And then otherwise, we just can leave everything as is, I think. Yeah. So that's all we're doing on this page. People who went through this yesterday, do it. If you did the DIA swath tutorial, you've gone through this, and it was somebody asked about these, what product ions from, product ions to. So this is helping us exclude the Y1, the B1, the Y2, the B2, which we saw were pretty problematic. And we don't need to raise the MZ. So another way of doing that we have here is we could say, oh, let's make the minimum 300, and that would also get rid of small molecules, which, as we saw, can have a lot of noise. But we can leave that. So let's just go ahead and click next. And here's where we have to tell it about our DIA. And in this case, we're using TOF with 18,000 resolving power, but we're also saying we want high selectivity extraction. which narrows the windows. It cuts the windows in half to say high selectivity extraction. That's going to reduce the signal that gets filtered, but it also it makes it more selective, and so we'll get less interference. And that proved to be really pretty useful in the Navarro data set, which was actually 3 different organisms, cell lysates for 3 different organisms, highly complex. But the only case, you might always want to use this, but the only case where you might consider not using it is if you have a very refined sample, like you just have a single protein or a few proteins in solution. And then we need to actually have a different isolation scheme. It's pointing to the one that we had before, but we're going to add a new one. So Natalie used a different isolation scheme. We'll call this Celev Sec 32 fixed. So this is closer to the original. This is closer to the original Swath manuscript, Ludovic Gillet's Swath manuscript. And we can click, we're going to do pre-specified isolation windows. We're going to get them from a file. Same way as yesterday, I created a little mini file that has like 5 spectra in it, but it has enough of the isolation scheme, or it has 50 spectra in it, has enough of the isolation scheme that Skyline can figure it out. So we click import, and then down into CelevSec and down to scans. And then we have this little MZML file, and I made it really small so that I can include it. If I had, these are like 5 gigabyte WIF files. So you're going to end up with a Skyline batch configuration that will allow you to run this analysis, but you're not going to do it here during this time, because this is an even bigger download. And if you had problems getting the Bruder data set down, you really want to make sure that you're on a computer with a high-speed network. So click open on that. Skyline takes a quick look and it says, okay, here's the isolation scheme I see. The measurement windows have a little bit of overlap. So 25 to 24, 50 to 49. Skyline takes that and halves it and uses that value as the margin. So it's saying, oh, you must be using margins. We can look at that as a graph. Now you can see that the windows are very constant. That's why I called it fixed. They're fixed size windows, about 25 MZ, 32 of them covering 400 to 1200. And if we zoom in to a range, you can see these margins, and we can turn those on and off to get a sense of the difference between what's getting acquired and what, the measurement windows versus the extraction windows, how Skyline's going to pretend these were collected. So that all looks good. There's no red or yellow, so no mistakes made. This is a good isolation scheme. And if you have that, everybody have that, click OK. All right, and then the last thing you need to do is this. So if I were going to do MS1, which we're not doing in this experiment, it makes things bigger and a little bit slower, and so I'm trying to get through these things fairly large scale, but like also make them pretty teachable. But it's definitely totally possible to have MS1 filtering, and then you can. I do believe that slightly improves your peak picking, and then it gives you another axis to look at things on, which is actually more confusing teaching. So that's another reason I don't do it teaching. But if you wanted to have MS1 filtering, a really good place to start is just to go count, and then figure out whatever resolving power is appropriate. Maybe 18 again. And then that would be a document that would do that. So I just have to go back here. See, it added a P there because if you're doing MS1 filtering, it needs a P, but it clearly doesn't remove the P when I turn it off again. So so anyway, this is now what you want to have on this page. MS1 filtering is definitely interesting, but an advanced topic that we're not going to treat here. So click next. So here we have the enzyme trypsin, which most everybody's using. Yesterday, somebody asked about miscleavages. In this case, we're going to allow 2 miscleavages. Again, we're still only going to end up using things that the DDA search found. So that's 2. It's not like we're allowing 2 miscleavages over the entire FASTA file. We are, but our targets are only going to be the things that are found in our library. So let's go. We're going to point to the FASTA file. And where is it? Oh no.
Yeah, I think if it's not there, probably sharing it through the chat might be an option.
Sharing it through the chat, you can actually, if I have it if I have a link to it somewhere, huh? Okay. Hang on.
Or you can add files, but I think they have to be in a Dropbox of some sort.
Okay, I'll find it. So wow, that's really disappointing. Whoops, not what I want. There it is. Okay, so I can take this and we'll go to, this is the drive that I've been using to share PDFs and things. So I'm going to drag it there. It's a pretty small file, I think. And yeah, so it's 10 megabytes, and I will get the link, share with anyone that has the link, and copy the link, and then I'll put it in chat. All right, so the link to the file's in chat. Sorry about that, folks. So now I will also download this, So had you just downloaded this, you could show it in the folder, and then you would need to get it to this folder, SelevSec. So I'm going to drag and drop it into the SelevSec folder. And now when I look at SelevSec, there it is. If I go back to Skyline, it's there too. So that's what you want. You want, and I'll fix the download zip file so that it contains it in the future. But obviously I left out a file. So that's the file you need. And you want to get that, point to that in this form. And then we're not actually doing any decoys or decoy generation or automatic mprot. We're just trying to get a template, right? Okay, so now I'm going to use my poll. And I'm going to say, I'm going to launch the poll and say, are you ready to continue? And I give, maybe people can just start answering yes. Okay, well, there we go. Some people are just answering no. Okay, so yeah, let's see how many people are actually doing this, and how many people. So yeah, like how many people want some extra help to actually get this. It would be great if we could have even more people succeed at creating the template. Although there is also a quick, short way of getting the template to run Skyline Batch. But we're going to, as soon as we have the template, we're going to switch over to Skyline Batch land on how do we set up processing for this. We're going to discuss what we want to do that. Should be, so do not do semi-triptych. Yeah, you could do semi-triptych, but yeah, it's, we're doing triptych here just to be faster. If you wanted to be more, if you wanted to be more alike, and I did some exploration of how do the results turn out if I'm trying to be as much like the paper as possible. So yeah, you can choose semi-triptych, trips and semi, and that would be more like the paper. You're going to get maybe 10 to 20% more peptides to search for. At this point, again, trying for the teachable, we're not going to totally try to mirror the paper, but you could. And I made it possible, and I've tried it, and you know this option was added based on reading that paper. I was like, whoops, we got to make semi-trypsin available. Okay, so now we have, well, it's great that we basically, it seems like we have almost 70 people following along, or we have 75. Yeah, we have quite a few. So 76. So, but we have 18 people who are kind of stuck. And I'll end the poll shortly. But if you're stuck, can you put in chat like what is there anything quickly that we can help? Are you you're not ready to continue because you're just a little behind, or you need me to go over something again? Like something was missing. So I'm going to end the poll. We got about 75% of people who are just like totally ready, all good, and a 25% behind. So I'm going to end the poll, and yeah, Q&A window for questions. So if you have questions that you need answered to catch up, go for it. If you're just like, I'm not done, but I'm hopelessly behind, just keep going. What you can always do, you can always do the cheat, which is what you need is all in this celebsec sky.zip, and you can unzip it here. You would just go extract all, and this will put you in great shape to run Skyline Batch. Extract all, delete the name of the first thing, and then extract right in place. I sure hope it will. So yeah, then it says, you've already, and I'm going to say, skip these files. I don't want to overwrite my files, but wow, that was interesting. Oh yeah, I didn't really want to get all, I got some things that were overwritten, I think. Wow, it overwrote my log because I haven't saved in a while, I guess. Okay, I'm gonna hope I didn't totally mess myself up there. Don't do that. Only do that if you really want to just be done and have the right thing. So I'm gonna relaunch the poll. We'll see. Do we have? Okay, so some people are just downloading the FASTA file. So we got the poll again. Should be pretty quick. Hopefully more people are caught up.
Brendan, there's a request to post the links to the Google Doc because some participants don't use the same computer as Zoom for the analysis.
Paste the Google, which Google Doc?
So if you go to the first tab that you have, May Institute.
This one. No. This
So
one.
yeah, this for the second.
This is the Google Doc for today.
Mm-hmm.
Okay,
Mm-hmm.
so here we go. So that's the Google Doc for today. It contains the presentation slides. The instructions are actually what we've just been working through, but we still have a way to go. So we have a few more things to do before our template is complete. So I'm about to click finish, but I was going to do one. So let me go back to the poll and do one more. Where am I? Okay, I got to go back here. Polls. Okay, so hey, 99%. Not quite as many people answered, but still pretty good. So we got 72 people answering. So we're gonna continue, and anybody who is hopelessly stuck is going to have to do the extraction before running MSStat, or before running Skyline Batch. Okay, so back to here. Share the results of the poll. Yay, there you all are. So now we can just click finish, and Skyline's going to need to then digest all the proteins. So I guess I should have had people start this even while we were waiting for the poll results, because it looks like it's going to take us a little while. Not super long, but and I don't know how fast everybody's computers are. But so we could answer more questions at this point. Yep, Ali shared it to. Oh, me to all panelists and attendees. Wow, I'm like not going. Huh.
Yeah, Brendan, you just need to switch it at the bottom, but I just sent it to everyone.
Okay, I switched to attendees now. So yeah, okay. Thanks to people thanks to the panelists who've reposted the links that I've posted. Okay, my future chatting will be to both panelists and attendees. Sorry for the confusion. Okay, well, that's going to take longer than I had not anticipated, that we would be waiting minutes.
And Brenda, there are 10 questions in the
10
Q&A
questions.
box.
So let's start answering some questions. So I'm going to start at the bottom. Is that possible to have different resolving power in MS filtering for different scans in the same Skyline document? So it's definitely possible for different scan types. So you can, but no, it's not. You can't choose scan by scan. But you can definitely say, oh, the MS1 had 100,000 resolving power, and the MS had 20,000 resolving power. See, that totally works in Skyline. So wow. Okay. Once you import data, build the mProfit model and choose that window, is there a way to look at the values of the model again, the window that pops up at the end? So we did that. So that's yes. Once you've done the model, we did that earlier with Brooder. You go edit, reintegrate, or you go refine, reintegrate, and then you'll see the model and you say edit current, and that will pop up the window and you can explore as much as you want. So that's what we did with the Brooder data to look at the mProfit model. And yeah, you get a very high level view of the model in the log of Skyline Batch. It just kind of tells you here are the coefficients and here are their weights. Here's the percentage of the variance that's attributed to them. So yeah, I'd highly recommend going back and having a look at the mProfit model. And we can look at that again when we start looking at the CelebSec data. So here we get something where we get to make some choices. It turns out that this is not a good time to make these choices because of and we're going to fix this too. But after trying this myself, I realized, you can't, when you're using a pre-built library, it's not a good time because we don't actually have our IRT model hooked up yet. And so making some of these choices at this point is going to cause us problems later. So just click, I would normally tell you to say, hey, we're going to do minimum two peptides per protein, which will reduce our false discovery rate because this is a big search across 40 files, and we're going to do this later. And I would also say remove duplicates so that when we do our quantification, we know that every peptide belongs to a specific protein. And you can choose to be broader than that if you want, but I'm not going to do that. I'm going to stay with one, and not remove duplicates so that I get absolutely everything gets passed through, and we'll filter it later. So just click OK. Don't do what I just did. And we're going to move on. So now we have this large list. You can already see some things that are included in this that say reverse underscore. So those are the decoys. Those are false discoveries, essentially. But we don't have an IRT model yet, so we got to keep going here. And so, yeah, in that case, if I would have far fewer of these reverse underscore things if I had restricted it to one, to throw away everything that has just one peptide. And that would also help us with our quantitative statistics, because quantitatively, we also have a problem. You know, single hit proteins are less confident than a protein where we have multiple peptides. So let's go ahead and create the IRT model, which you saw got automatically created when I built the library myself, but does not get automatically created when I bring in an existing library. So I have a, so this library contains an IRT calculator in it. So what I'm going to do is go to prediction, add retention time predictor. I'm going to add a calculator, and I'm going to name the calculator Celebsec 90, and I'm going to just open it. I'm not, creating a new calendar. I'm just, oh, whoops. So that's not what I want you to use, and that's only there because I did the unzip. So I want you instead to use this blib. Hopefully that's all. Hopefully you didn't, when it was IRTDB, you didn't see anything. And so you got to go down here and switch the file type to blib. And this blib contains an IRT database. So click open. And so now you can see here are 14 standards. It's saying that, well, I got to find at least 11 for this to be a valid thing. That's just the way things work. And then you can see that there's almost 65,000 peptides in there. Yeah. And linear regression, everything here is fine. We don't need to change anything. And then this is another strange bug that I found in working on this, but when we click OK, it says, hey, you can't modify this spectral library. We need to create an IRT calculator as a new file. So you say, okay. But this message shouldn't be happening either. That's going to get fixed. We're going to save it. If you don't have, so again, because I unzip things, I'm showing up at the name that I want. But if you didn't have that, you would just say Celebsec 90. And then click save. So just don't, Skyline will add the extension. You don't need to, we're going to call it Celebsec 90. For me, it's going to say, hey, you've already got one. Do you want to replace it? I say yes. And all that's doing is pulling the table out of the blib and putting it into a separate file. So it's unfortunate that it does that. It's unfortunate that it didn't recognize it in the wizard. But this is what we have to do because we're going a little bit off the normal path. The normal path being building your own library. So, so that's it for that. You can go ahead and OK the peptide settings. And now the last thing we need to do is go back and apply that refinement that we skipped. So you go to Refine Advanced. And this time we're just going to say we want two peptides per protein and remove duplicate peptides. And if you were trying to go for the biggest list possible, you wouldn't do these steps. But because I'm teaching and I'm not trying to go for the biggest list possible, I'm doing some things that seem pretty reasonable to me But there are other people who are like, no, I just want absolutely everything. They're going to decrease my false discovery rate for sure. And then it's up to you to think about like, well, will my statistics protect me, or is it a good idea to reduce my false discovery rate? And some people feel like I'm going to miss something, and maybe Olga will talk a little bit about that, because you can miss something because you're missing the signal, and you can miss something because you have too much noise to see the signal. So, okay, let's click OK. And now you can see that all the reverses that we could see have disappeared. And then I'm also going to do refine sort proteins by name. And that almost always brings the reverses up toward the top. So you can see that I now have, in terms of, like, I passed these all through. These were invisible to my search engines. They didn't know about these reverse underscore proteins. I just pretended they were part of my sample. And so this is a reasonable assessment of what the false discovery rate looked like to be pretty low, especially if you were using something that was built from 40 fractions. And so in this case, we just have two peptides, or two proteins with two peptides each. And so extremely low false discovery rate. And we're going to go ahead and delete them both. So you just click and control click to select them both, and then press the delete key on your computer, and they're gone. So we're not going to take them forward any further, but it's nice to have that as a sort of feel good. Oh, okay, my false discovery rate at this point is pretty low. And let's go. So yeah, so that should leave you with a final count of 3,597 proteins, 38,000 peptides, 50,000 precursors. So these are lower numbers. There were in the paper they're like 80,000 and 60,000, and you can definitely go through things like using semi-triptych and loosening things up, and you can get Skyline to have those 80,000 precursors and 60,000 peptides, but we're not doing that here. Everything has 6 transitions. We have, we have 300,000 transitions in this document right now. And you should, if you follow along perfectly, you should have exactly the same thing, because Skyline is definitely deterministic. And if your numbers differ at all, it's because you missed a setting, and you should go back and review the steps again. So settings, last thing we're going to do, document settings. We're going to add these annotations and reports. We're going to add MS Stats Input Plus, and so we're going to add the 2 reports, MS Stats Input Plus and precursor peak areas scored. We added those the first day. We're going to add the 2 annotations for MS Stats. Click OK, and that is the template. So we can just now save it, and we have a template ready to go for processing in Skyline Batch. And the processing in Skyline Batch is going to be a little bit more complicated today, but thankfully there's a way to save configurations and restore them right into Skyline, and I'm going to hand things over to Ali to talk about that. I'm going to I'm going to close Skyline on my computer, and hopefully people are relatively caught up. And if you're not, and you want to go onto the Skyline Batch, again, you can go here. You're behind, you just didn't follow along at all. If you want to get to where you can run these Skyline Batch things overnight, go ahead and use this extract all to set yourself up. And now Ali's I'm gonna stop sharing my screen, let Ali share hers, and she's gonna take you through the next step.
All right, hello again, everyone. I'm going to quickly go through exporting and importing configurations. Like Brendan was saying, the configurations that we're going to be importing today are a little bit more complicated, and there's also five of them. So given the time it took to make the one yesterday, we're just going to be importing them so we don't have to go through that whole process again. So this is my Brooder configuration that I ran very early this morning. And to share it, I'm going to click this share button. And then you select whatever configurations you want to share. Since there's just the one, I'm just going to select the one. And then if I come down here, I can save this as a file, and I'm going to call it Brooder only. And I would recommend saving this in your NEU 21 Skyline folder, and you'll see why in just a second, because I'm going to open it in a text editor. And I have it saved to the wrong folder, so let's fix that. And I already have one here, so it's going to ask me to overwrite, but you should not have one there yet. All right, so I'm going to come into File Explorer and open that configuration that I just saved.
Ali,
Yeah.
there's some questions with regards to the Skyline batch running that is still running from yesterday. And someone has now been able to open a new file because it's still running. What should they do?
Open a new file, open a new configuration. I'm not sure quite what they're saying
Well,
there.
if it's still running, what phase is it at? I mean, if it's just downloading files, they might as well just stop it at this point, and they can come back and download the files again later. If it's in the middle of running MS Stats, I don't know. I mean, still, you can all of these things you can yeah. It may be most helpful for them just to stop. There's definitely ways that you can resume from any point. And Ali can just show you that with the run all steps. There's a little drop down. So you could actually, if you had made it through certain points, you could just say like, so if you'd made it through everything but running MS Stats, you could say, oh, I just want to run the R scripts, and then that will run MS Stats. So so I would say, yeah, stop it and follow along with Ali. You'll get more out of that.
All right, I'm opening this configuration just in Notepad++ to just show you guys what it looks like kind of as it's XML bones here. And you can see it's pretty much just verbatim what we put in yesterday. We got the file paths to the template file and the analysis folder and everything in there. And so this is what you could share between computers to have your friends run your configurations. And Skyline Batch actually does some pretty cool path replacement that allows it to replace the root of any path on a different computer. So it can be pretty nice to share configurations between computers. And we'll see that in just a second when we import our configurations for today. All right, so coming back to Skyline Batch, we're going to click Import. And then we're going to navigate to our NEU 21 Skyline folder, which should now have our configurations file and our Brooder only file. And this configurations file is the configurations for today. So we're going to double click on that. And it's going to ask us if we want to overwrite our Brooder configuration. The configuration called Brooder that we're importing now is exactly the same as the one we currently have. It just has an extra report that I'm going to explain in 1 second. So we actually are going to overwrite our Brooder configuration from yesterday. All right, if everything went well, your configuration screen should look like this. There is a possibility, especially if you were using our version 4.0.5 yesterday, that some of these configurations are red And configurations are read when they're invalid, so they couldn't find one of the files or R versions or Skyline versions that they are used to on your current computer. So if you are one of those people who has a read configuration, I would encourage you to double click on that, and you should see the configuration, the invalid configuration setup kind of helper there, and that should guide you through changing the R version back to R 4.0.3. I'll give you guys a second to do that. If you do have any read configurations, you will have to do it for every read configuration. So just work your way down the list there. While you're doing that, I'll quickly go into this the Brooder configuration, just to show you the new report that we have added since yesterday. You can see everything on this tab looks exactly the same. And then we're going to come into reports here. And in addition to this MS Stats Input Plus, we also have this precursor peak areas scored that Brendan was talking about yesterday. And that just runs this little detection.r script here,
which I wrote. So this is an example of, you could write your own R script. Like you can download a great R package like MS Stats, or boy, if you just really want to run some R scripts on a report exported by Skyline, you can write your own, and we'll run that in a moment, and I'll show you what the output looks like.
Yeah. And if you are writing your own R script for Skyline Batch, it's important to know that you will get the name of the CSV report file as input to your R script, and that's how it will be receiving the input there, and then you can read the data from that CSV. Brendan, are we going to be explaining the celeb set configurations now, or?
Yeah, I'll take back over. Thanks, Allie. That was
Sounds good.
great.
Mm-hmm.
So I'll share my screen.
And if anyone has any issues, just put in the question and answer, and I will try to get to those.
So that was so easy that I was able to just switch over to my computer and load those configurations. Also overwriting the one that had the runtime from last night, but I still have my my log from yesterday here. But yeah, so what I did for simplicity, because the MS Stats run were taking so long, is I created 3 configurations, which are actually, they're just copies of these original configurations with MS Stats added, or these ones have MS Stats removed. So if you run one of these configurations that doesn't say MS Stats, it doesn't actually run MS Stats. You can, if I double click on this, if I look at the reports, you can see here in the CelebSec reps, again, I'm exporting the peak areas scored report and running the detection R, but not MS Stats. Same here. There's now here I'm exporting the MS Stats plus report, but I'm not running any scripts on it. And then same here. So that was just a way that I could get through this stuff pretty quickly, and then come back later for running MS Stats inside Skyline Batch. And the way I created them was, there's this, so if I have low CV, I can click copy, and I just get a copy of this that I can now rename something else and save it. So again, and so now I have another, and that can be a really quick way to play with some things, like we could create a copy of this and say, you know what, I actually want to change the MSMS filtering resolution or mass accuracy. So I'm going to run CelebSec with 10,000 resolving power. Or I could change the retention time, or so there are reasons to create copies with just slight changes, and then you can run things a bunch of different ways overnight, and you wake up in the morning and say, well, how did they do? But in this case, we have copies so that some can run MSStats and some don't. So why do we have 3 configurations for Celebsec and just 1 for Bruderer? That is because we're as I said this morning. Let me just quickly switch. We were gonna is that gonna work? Whoops. Hello. What's going on? Oh, Slido. That's not what I want. I have too many windows up here. Where? All right. All right. So we're going to do a refinement experiment. So we created our template. That's building our method. The method was run on, the mass spectrometer was run on some DIA samples. It was run in a certain way that is going to allow us to evaluate the results for repeatability. And then from that, we're going to create a new method. We have a separate data set that we've collected on the mass spectrometer, and we're going to go through and evaluate those results. So the way that applies here is Celebsec reps. I should be able to get to. So this is the one I've been working on. I think Celebsec test is a fully completed one. So I actually have 2 data sets that come from the Celebsec paper. There's one where they just did eight reps. No perturbation, no nothing. It's just, these are technical replicates, right? 8 times, which is great. I was very excited when I saw that. So that allows us to analyze this with DIA and ask which of these peptides are really consistently measurable, right? We want things that we're going to have low CVs, because if we want to do quantitative analysis, we'd like to have something that is measurable repeatably, and that's I think that's applicable at this level. Certainly it's applicable if you're gonna try to take something to a clinical quantitative assay. You need to do much more extensive repeatability experiments. Andy Hufnagel, who we work with, suggests like a 5x5, where you do 5 replicates on 5 separate days and look at the CVs for those. And then this is the osmotic shock experiment. This is the true quantitative experiment that we're interested in. And so what we're doing here is we take the Celebsec reps experiment, and then here's where we actually apply some refinement to it and export a new Celebsec low CV template. So we're creating a new template document. We start with our template document, which was just like really wide, all the things we thought we might be able to measure, and we're doing a refinement experiment using the reps data. And then going forward, we now have two ways of looking at the data. We could either look at just the low CV peptides, which are peptides that we're able to achieve under 20%. Well, we can actually look, what was the refinement that we applied? So we said, okay, so minimum peptides 1, that just means like get rid of some proteins are going to have no peptides that meet this standard, so we're just going to get rid of them in the document. Maximum precursor only, so we're only going to take the best precursor. So if we have a peptide that has 2 precursors, we're going to get rid of those. So you know that since we had quite a few more precursors than peptides, we're starting out with a lot of peptides that have multiple precursors, and we just want the best one. And then we say, okay, we're going to use equalized medians normalization. And that definitely gives us better CVs, and we can go look at that. And then we're gonna throw away anything that after that normalization, anything that over those 8 replicates was not able to achieve 20% CV, we're gonna throw it away, and that's gonna give us what we think we're gonna see next week when we look at this with Mina Choi, is that we're gonna get better CVs, better quantitative statistics in our final analysis when we analyze the quantitative data, the osmotic shock data with either low CV or, hey, we're just going to try everything. So the experiment here is, can we improve what we get out of MS stats if we give it cleaner data? And so then the final cutoff thing is we also say, hey, if we couldn't detect it in at least 4 of the 8 runs, we're not interested in it either. So we're saying high reproducibility of finding the thing, and then once we find the thing, that we have a pretty good CV. So that will cut out a fair number of stuff. And again, we want to ask ourselves, is it more important that we might lose signal? If we improve noise a lot, we may actually, at the end, we may have more signal quantitatively because we cleared up the noise, right? So whenever you're measuring anything, signal and noise, the how well you can measure it is determined by the signal to noise, and you can either have a lot of signal, or if you decrease the noise, you can still decrease the signal. And that's the mass spectrometer doing SRM and PRM. Those are all about decreasing signal, and they also they decrease your signal, but they decrease the noise so much more that people do them. So we hear a lot in proteomics, like, oh, if I do something like this low CV experiment, I'm losing all these things that I could be measuring and all, but you're also losing noise. And so I think we're going to see that you get better in the end. You get better quantitative signal out of MS stats, and that was what this was designed to investigate. But yeah, so a couple of years ago, I said to Olga Vitek, wow, I think we could just do everything, all the processing with batch files. And now I think we've done it even better. We're using Skyline Batch, and you can run through all these. If you've done Bruder, you can just, start running these. This is the way I do it, is I would just run all on these first ones, and then to run MS stats, I just click this, and then I go run from the R scripts. Or you can also just go, if you just want to run everything at once, running this set of configurations will run everything, right? It will go all the way, just like you did yesterday. Yesterday you essentially just had this Bruder MS stats configuration, which if I run this now, this will run everything again. It'll probably actually tell me that I already have results. But yeah, and then so this is my own R script. This one has only my own R script, and so let me show you run only R scripts. So I have a fully processed Bruder data set from yesterday, and I can say run only the R scripts, and that should because I have to run reports, because I didn't actually ever export that report either. So if I run export reports, I guess that's probably gonna, whoa. Huh, why does that not exist? Oh, I named it wrong yesterday. So this is what it was. So I typed ppm 10 C, and it's so all my results. So I will just delete that. That's an empty folder. And if I rename this, then now I should be able to go back and run from export reports. And it says MS stats. Do I want it? So now this is telling me like, hey, this is going to overwrite your MS stats. What is this going to do? It says running. Step 4 will overwrite the following exported reports. So what is this? What's this other one?
That's the output from the MS stats. It's reading it as a report since it's a CSV, but in fact, it's just the output from the MS stats.
Oh, okay. So it won't actually overwrite it, right? I don't know. It doesn't matter. I'm going to go ahead and continue.
Yeah.
So it's going to open my template file, which again is a big file. So this takes a few seconds. So while it's running, we will come back. So we're actually, this is up to the allotted time. I'm going to stick around for questions for a while if people have questions, want to work through things. But your assignment for May 11th, when we come back and talk about this stuff with Mina, would be to at least run these sets of things. So SelevSec reps is required to run these subsequent things. You can run them as I have usually done, which is sort of in a set of steps, which I would usually select all these three, run them from the entire thing, and then I would go back and select these two and run only MS stats the way where, so that would be run from step 4, run only the R scripts. So if that's too complicated for you, then you just have to run these 3 configuration reps, low CVMS stats, and SlevSec all. And that will give us more to talk about immediately with Mina. If everybody has actually run MS stats and has, you know, all of these PDFs in their files, and then we will also, during that May 11th session, we'll go ahead and we'll open up a process selevsec.sky and do some of the same types of assessments that I showed you. Actually, we'll open up one for the reps, and you know, we'll have 3 processed files for SelevSec, and we'll go over those results. But the challenge for you, if you're listening, is to actually get all those run yourself, so that you have this stuff sitting on your machine when we start talking about it. So let's see how's the log going. So it's still, I guess, yeah, the MS Stats Plus report is a pretty long report, and we don't even strictly need it, but this configuration has it. What I'm more interested in is the peak. Oh, this is the peak areas. Oh, it wrote the peak areas. The peak areas got written really fast. You can see that it has a row per precursor, so it writes out quickly, and the MS Stats wants all of the transitions, so you can see it's writing 4 million rows. MS Stats runs on much more detailed data, but we're getting there. Let's see, are there questions? There are questions. Tried reinstalling, got the same error.
That's a Starline batch error, Brendan, which I would love to go over with you, Lisa, later. If you can share your screen, that would be really great to take a look at and figure out what's going on.
Somebody asked, is the library compatible with OpenSwath? I think that there is. So it's not like OpenSwath, I don't think has been made to read .blib files. That would be up to them. I think that'd be a great feature, but it is possible to export a report from Skyline that can be used as a library in OpenSWAT. And you would have to contact the OpenSWAT team to get that. I know that Spectronaut also has a report format. So just like we're exporting this special report for MS Stats, Skyline has incredibly flexible reports, and anybody can save and share a report template with you. I know that Spectronaut, the diagnosis team, for a while had a and I have a pointer to it on Skyline somewhere, a page where they explained how to export a report from Skyline that could be used as a library inside Spectronaut. So hopefully, yeah. But go talk to the OpenSWAT team about how to get the library working in get a library from Skyline working with OpenSWAT. So you can see the R script is running right now. This is just my own cobbled together R script that I found really gave me a lot of interesting information. And once you see the PDF, again, it's like, I think this is incredibly useful if you have any hope of learning R, and there's a bunch of, we're following this on with beginner R and advanced R. If you have any hope of learning R, I have found it to be really incredible. A prototyping area for Skyline. You're going to see, when you see this set of plots that I have in PDFs, they're gonna look very familiar because we've already looked at similar plots in Skyline, but it took us years to implement these plots in Skyline, and I had them, implemented in a day or two using R. So if you can learn R, and if you can learn about how to export these reports from Skyline, it can make what you can do with Skyline incredibly, and now with Skyline Batch, incredibly more flexible and powerful. So I highly recommend it, and it's now optimized with Skyline Batch. Okay, back to questions. Does the batch, Skyline as well as MS Stats, use all available CPU processors? So does it help to have a lot of them? MS Stats does not. That was one of the things that I found. Skyline does. Skyline will consume. I think it does a good job of not making it so consuming that you can't actually even do any work. But it will. As I showed, I have this other. Oh, we couldn't get on it. I have this other computer that's like 48 processors, 190 gigabytes, and that can run the Skyline side of the processing faster than this computer, whereas this computer runs the MS Stats processing faster because it only has 6 CPUs, six cores, but they run faster than the one that has 24. So, but yeah, having if you're going to do this kind of large scale processing, having a good amount of memory and faster processors, seems to me pretty cheap to get a hex core i7 processor now, and that's what I would get for a desktop if I were buying one today. Okay, so that finished. So now if I go back to Bruderer and into here, this is my little CV. Actually, I wrote a CSV2. These peak areas things are things that I just create, or that my R script, and I'm not going to show it to you, but but let's see what it did. So using the same data, it did a detection plot. Hey, that's the one. This is pretty much, I used this as the spec for Rita Chupaloff, who did the detection plots in Skyline. I said, hey, make this possible to do in Skyline. So these are just several ways of looking at it with, this is with less than 20% CVs, and there's applying certain, and then this is that other detections histogram I showed you, and then hey, wow, these are like we haven't looked at this CV histogram, so these are also available in Skyline. We can look at them next time, but yeah, this is just showing you, what do the CVs look like if you took them across 24 runs. And we're not actually these are not amazing CVs, but neither are these things expected to be technical replicates. We're doing some sort of perturbation on these, hoping that certain things are going to change. So we'd have to read the Bruder experiment to understand how good these CVs were and what we're really expecting here. But you can see all these plots are, and then these are CVs by intensity. This is a 3D histogram. And so a lot of these things have made their way into Skyline, but this is, when I didn't have these tools in Skyline, I was able to produce them with R. So highly recommend learning that and using these tools. Okay, so that's it for our time today. I'm going to stay and answer questions. And what I would recommend is that you at least do CelebSec reps, and then so you at least run these 3 configurations, and you're welcome to run them in steps where you run these 3 configurations and then you go ahead and run this one separately. But when you run these ones separately, you want to make sure that you start from the R scripts. Okay, so back to questions. I'm going to stay around for questions. Thanks to everybody who came. You're released. The official session is over. And let's go with, I guess, back to the bottom. These course tutorials and sessions have been great and I follow along no problem, but I'm a bit confused about the big picture of what Skyline does. What process steps must be followed such that I get confused when I process my own projects. I think it's because I don't fully understand the rationales behind the steps. I've tried some of the website tutorials and some improvement understandings. Is there a manuscript or webinar or document you suggest for understanding the workflow in general and its rationale? Yeah, it's Skyline, and what's all the things that Skyline can do are somewhat nonlinear. It's not a completely like here is a set of steps and you get a specific output. We still are trying to enable a lot of different things that people might be doing with these data. So the tutorials are definitely a great place to go. And let's see. Yeah, I don't have a great paper to point to at the moment. Okay, understand, and yeah, I'll work on the big picture. Anyway, I'm gonna have to defer on that question. Maybe I can come back and give some pointers other than reading the tutorials, and there are whole courses that I hope would go through things like, if you haven't, again, to some extent we expect at May Institute that people are coming with more of an initial basic understanding, but and I just realized kind of late that we lost this whole 2-day session that would really introduce you a lot more to Skyline and why you would use it, and how you would use it from the beginning. So, but there are a number of recordings, fully recorded courses, and you can go down here and go to these YouTube channels, and these courses really take you from the beginning. So if you went to this UW course, you could start a lot earlier. Like, wow, that went too far ahead for me. I would like to go, day 1, mass spec basics, day 2. So you could maybe just do the first 2 days of the 2018 course, and that might give you a lot more perspective. Okay. Could you show how to generate variable DI window isolation list for Explorus 400 using Skyline? Sure. So, I mean, I might just, so we have this is the Bruder template. So there are existing isolation schemes that people are using for thermo instruments. And this, you want a variable window. So the McCoss lab itself is not doing a lot of variable windows, but this is, this is what Biognosis used in the Bruder experiment. So this is variable window, and you could ask around other places, maybe even post to the Skyline support board, what are other people using for, this is an older Q Exactive probably, and people may be using more windows, or maybe not. But this would probably be a good place to start. So actually an Explorus. So does an Explorus have a quadrupole? I mean, does it not have a quadrupole? Does it have an Orbitrap? I'm not totally on top of the. Is an Explorus a hybrid or an ion trap with a quadrupole? Does anybody know? Juan, anybody?
It is. It is. Actually, I think it's the newest versions of
the Fusion
thermal instruments. Yeah, newer than the Fusion. It is quadruple Orbitrap.
But it's a quadrupole with it. Yeah. Okay. So yes, if you've got a quadrupole, if it's a quadrupole Orbitrap instrument, this is probably a decent method to start with. But you could, I don't think this. So the newer quadrupole Orbitraps have a much brighter source. So you might, and maybe they have higher scan times. So you have to think about when you're doing these things, like this is 19 windows, you have to think about the scan time that's required. And there are whole lectures on designing these methods. You have to think about your chromatography, your peak width, how many points across the peak you can get. And yeah, I don't have an out of the box one that I can point you to, but you can hop up on the Skyline support board and say, hey, is anybody using variable windows with an Explorus? Because in our lab, they're not using variable windows, but and somebody might give you an answer. All right, so Orbitrap, QEHFX. Okay, great. So thanks for all those. Everybody gave me. So yeah, it's basically a QHFX sort of, but so was the Lumos. Where can we find a one-day mass spec course for beginners that Brendan just mentioned? One-day mass spec. So again, yeah, I don't know exactly, but you can get to more beginning material than was presented here on. So we dove in at the far end of the pool, the deep end of the pool, as I said. If you want to get in the shallow end and get a little bit more step-by-step instruction, I think especially on Skyline, I think going to these YouTube videos, which you can get to on the Skyline install page where you installed. If you scroll down here, there's information about webinars, tutorials. And there's also this join us section is actually instruction. And so here's the May Institute listed. And then down here are some YouTube channels, which actually has past May Institutes, past courses at ETH, and past courses at UW. And the UW courses are going to be the most basic. So the most basic you're going to be able to get for Skyline instruction is to go back to 2018 day one and follow that, and then you can go as far as you like, and then eventually they'll by day 4 we're transitioning to DIA, and you may kind of go, oh yeah, I went over some of that, but there's a lot of DIA background that you might be interested in still in there. So that's definitely worth looking at. So from yesterday's Skyline batch run, I got the following error. Error in Skyline MStats format. Have multiple conditions or bioreplicate. Please help. Thanks. Okay. I think we're going to have to, something must have been wrong in one of the, but yeah, I think we'll have to defer to Mina. We'll be back to work with you on that one.
Brendan, based on that error, I was thinking that it would probably be an error in the template creation of the Skyline batch settings, because otherwise their report should have been able to run.
Yeah, so I guess it would help to be able to see the rest of the log file. So if you can somehow paste the lines before that, like is there an error that Skyline's happening, like it can't import the annotations, or there's something that we definitely discovered that there were some errors that could happen in Skyline that we wanted to make it so that they would stop MS Stats, so that MS Stats wouldn't even run, so it'd be more obvious that, hey, Skyline had an error. So that can be a problem. So I'd say first look up and see if you're totally positive that Skyline ran completely successfully, and then maybe look at the report and see what the report looks like. I'm a little stuck right now. I followed along setting up Skyline and then changed the R folder directory to Skyline batch. Now I check the boxes as Brendan, but I cannot click run all scripts button as it is gray. So is that, have you answered that, Ali? Or are you are you positive that is everything black like this, or is there some red?
Also, if they have checked configurations, sorry, I don't know if they said that already.
If they have, if they don't have any check for configurations, what?
Yeah, or if it's already running, then it would also be gray.
I guess it doesn't look like it actually grays it when I don't have anything checked. So
yeah, that's true.
So it looks like you must have something running. Maybe click the stop button, or yeah. So the stop button is grayed out because I don't have anything running. But I guess if I went back to and said, hey, let's do Bruder MS Stats, run only the R scripts. Wow, it didn't tell me I was going to overwrite anything, but so there you go. Then I stop it. So, or actually, I guess run it, which would, if I go back here, now it's grayed out, and to get it ungrayed out, I need to stop. So that may be the issue. If I read search DDA data into Skyline and then want to narrow the target list to just a handful of proteins, I assume, do I have to manually delete the others? Can I search for just the ones I want to keep? Yeah. So I'll just bring up Skyline Daily. So let's bring up this Bruder template again, because it loads pretty quickly. And then there's refine accept proteins and refine accept peptides. So that's a great way to get a list of things you want to keep, right? So these are the sets of things that you want to keep, and you can do them by accessions, preferred names, whatever, and then everything else will just go away, but it will keep your standards. So even if you didn't say IRT is something you want to keep, it should keep your standards. So that pretty early, because we were doing these refinement experiments, we're like, oh, I did all this statistics and I figured out that so you already know a set of things that you want, and you can either, if you were here on Monday, Lindsay took you through like getting FASTA for exactly the proteins you want and only inserting that into Skyline. That's totally possible. But if you ended up with everything in Skyline and then you just want to narrow it down, you can use accept peptides, accept proteins, accept peptides. And that acceptance can be the result of like running MS stats and going like, okay, wow, I figured out, you know, I now I want to do a narrow experiment and there are 20 proteins that I want to look at, and MS stats told me which ones they are, and then you would use accept proteins and accept peptides. The other thing is that we haven't really touched too much on the document grid, which is what is the backing of all of this, of the reports that we're exporting. So, but you can do filtering here. And you could do a contains filter. So you could go contains P60, whoops, P6, let's say contains P6, or contains P60, or let's say it starts with that. How about that? Starts with that. And then we go, okay, and there's just 28 things. I guess we would have to then select these, and we could go refine accept proteins, paste them in, and click OK. And then now we're down to just those proteins. And wow, it did take out the IRT. So usually we try to avoid that. So I'm going to say you would have to also add IRT as your one of your protein names. So luckily we can undo everything, and we would go IRT, and then everything, and click OK. And now we didn't get rid of our IRT, but we narrowed our list down quite a lot. And so I'm going to undo that again. And now we could also filter does not start with that. And we go, okay, so now we have actually 3,838 that don't start with that. And we can just select all and click this red X button, and it says, are you sure you want to delete everything? We say, yeah, totally. And there you go. We've deleted everything. We're back down to 28 proteins. So those are several ways we can, now I'm going to go back, and I think I still have that, but I'm going to delete everything except for this IRT row. And so it really just depends on your selection here, and you can do fairly massive deletes and filtering. And so lots of power, lots of things that can be done. I definitely recommend that people learn how to use this report grid. It's very, very powerful. I'm going to undo that, get back to my file. All right, so can Skyline recognize .tsv spectral library from DINN? I'm not sure. I think that question was asked yesterday. Try it, and if it doesn't work, just like pop up on the support board and say, I really want to use the spectral library from DINN, and supply one. Here's the TSV, and I guarantee you that we'll have it implemented relatively quickly. So within at least, probably no more than a few weeks. So that's, as we showed yesterday, we have extensive support, and the things we're missing are largely just they've never been asked for. I can't think of a thing. I can't think of a spectral library format that somebody has asked us to support that we have not supported. So, okay, DIN does not work. So please help us out by give us examples, because we don't run DINN. So we're gonna need examples, and then we can adapt the software to support it. It would be a nice option to queue up jobs in Skyline batch. So what does that mean, to queue up jobs? Because that's what we're doing. Like we can, definitely I queue up all these 4 and then run them. So I don't know. To me, you can queue up jobs. You can run infinitely many jobs, as many as you want. And you can run them overnight, go to sleep, and come up and get them in the morning. So if you're talking about a more complicated queuing system, like where you could like you have things queued up, and you can say, oh, whoops, I want to run them in a different order, or that, like, if you want an editable job queue that then you can interact with, that's a great idea, but it's not something that's implemented. So, but yeah, that might be cool as a next step for. I have definitely things that I consider more important for Ali, but at some point maybe she'll get to the point where we say, yep, okay, there's a job queue now, and you've just added things to the job queue, and now you can change, if they haven't been run yet, you can change the order. Lots of possibility. But okay, so if that's
you
what
actually
you're suggesting. Oh,
can change the order. If the configuration is checked and you decide that you want to run the last configuration next, you just put it at the top of the list.
Oh, well, there you go. So it is essentially already a queue, and we do allow you to change orders of things. So if you want to change orders of things that haven't been run, apparently that already works. So Ali must be, when she finishes the current job, she looks at the order at that moment rather than sort of storing it. So it is sort of a job queue already. Okay, why do we need the option to edit isolation scheme? Is there any instance when the isolation scheme in the raw data will differ from the one I want in my Skyline document? Well, it's frequent. You may design an isolation scheme before you acquire any data, and Skyline allows you to do that. And yeah, if you have a raw data file you want to analyze ahead of time, I would highly recommend that you just point Skyline at that. I can't say for sure that will always work. I did my best job, and I haven't run into any files that have failed that. But this gives you sort of the ultimate flexibility here. Like I definitely don't want to say, oh, yep, it's got to always be choosing an import. If you prefer not to import, if you prefer not to specify this isolation scheme, I guess maybe that's the question. You're saying, like, why not just always use results? And the reason that I explained before is that knowing the isolation scheme gives you a chance to know which precursors and peptides you could actually monitor. So for instance, because we have this pre-specified isolation scheme, we know that you can only monitor things from 400 to wow, this is no scroll bar. That's weird. You can only from 400 to 1200. And then, if you had a gap in here, Skyline would go, oh, great, I can't measure anything. Suppose you had a gap of 100 or 200, then Skyline would not include any precursors. So having foreknowledge of what the isolation scheme is allows Skyline to come up with the targets. You may be coming up with the targets in the isolation scheme before you have any raw data. So this is, yes, this is pretty flexible. If the question is, why wouldn't I just always say use results to use the isolation scheme in the raw data? It's because it's useful to you and Skyline if you and Skyline have a prior contract on what the isolation scheme is going to be in all the files that you import. Each one could be different, but you're saying here, like, no, this is the isolation scheme. Please make sure that none of my targets are outside the isolation scheme. It makes it possible to say this checkbox says use DIA precursor window for exclusion. So that's saying don't extract any ions out of my precursor isolation window. So it makes having foreknowledge of the isolation scheme makes target editing, it can be much more rich. Forgot whether the iProfit file can also be used in this case. What settings can you change to be more restrictive in regards?
I could give you a little bit of feedback on the one that was addressed to me because I'm not sure how to answer it. It's
sure, go
related
ahead.
to a previous. So
One,
this
would
person made a
right-click
previous.
on the
Yeah.
remove untick. So it says one, would right-click on the transition you want to remove and untick the quantitative checkbox solve your concern. So is that this sounds promising? Small additional question. Peak boundary placement. It will ignore said signal.
So after you take a transition from not being quantitative, if you go through peak picking again, will it consider those transitions for defining the peak boundaries?
Yeah, that's a really good question. I don't even know the answer to that. But I'll find out. I think that's true. It shouldn't, it's like, because you may have said it's non-quantitative because, but yeah, Nick is the one that implemented the non-quantitative transition. So before he implemented it, we were definitely considering all transitions. I agree that it would be a bad idea to consider them. I mean, I know that we're not considering them in like scores, but I don't know. I have a vision of the code that sets the boundaries on the peaks, and I don't know whether Nick correctly excluded non-quantitative transitions from that. So hopefully he did, but if he didn't, that's a bug. So yeah, we would. I'll. Yeah, we gotta go ask him. Let me see. I should take a note about this. All right, so I mean, Nick's a pretty smart guy, but there's clearly a bunch of different places in the code where we use chromatograms, and so that's a good question. Okay, so a general question on choosing the number of transitions to use. Should this be dependent on the length of a given peptide? Is it possible to adjust the required transitions for a peptide call based on peptide length? It is not, and that's not the way it's done typically. So I'm following the general way that people do things, the standards. The thing about a long peptide is it's also going to have a more complicated spectrum. So it will have, this is a classic scoring issue in DDA search, is that actually both higher charge states and longer peptides separate into different distributions. So there are these things that will cause the scoring algorithms to distribute differently, and certainly the natural complexity of the spectrum is an important part of it, because it's like if you're just counting ions that you found, then a long charge 3 peptide is going to have lots more peaks in the spectrum that match the peptide, because it can fragment in a lot more places, and it's more likely to have both charge 1 and charge 2 fragments. So that's definitely an issue for DDA search algorithms, and that's not what people are doing in targeted. They're saying, look, you know, actually things behave fairly similar if you choose the 16 best transitions to look for, and that's been tried a lot. I have not seen anything that says like, hey, if I have a hope of finding 20 or 15 different, then I would like to have 15. So there's nothing in Skyline that would allow you to scale based on how many transitions are expected. So good question. It's definitely a consideration in DDA, and at this point has not been a DIA consideration. I forgot whether this mentioned earlier. But is it better to process DIA using TOF because of speed? What is the difference if Orbitrap was selected as the MS analyzer in the setup? So, it was mentioned yesterday. I recommend at this point, if you're in the full scan tab and you're using a thermo instrument, use mass analyzer centroided and use mass accuracy. It allows you to exclude a lot of stuff, and you'll get much better peak picking. And it doesn't have we don't feel like it. We actually feel we were worried it would have a negative impact on quantification, but it hasn't. If anything, it's a positive impact. And that goes for thermo and Bruker, which is a TOF instrument. But centroided, the Bruker data, the Bruker TOF data is so big that it will be really slow to process the TOF data. And their files, both thermo and Bruker, their files are stored in a way that they have the centroided spectra immediately available. And so it's actually faster to process the centroided data, and we see good benefit. There is a centroiding algorithm that SciAx has that we have used on their TOF data, which has had a slight improvement, but it requires running an external tool, and creating a second file. So there's enough complexity that at this point it's not a big enough benefit that I would tell a lot of people to do it. So I say, if you're using SciAx data, go with TOF. And then similarly, if you're going to do Waters data, at this point, hopefully you're doing HDMSE using their iMobility, and that's going to give you a good benefit, and they don't have a centroiding algorithm for that yet, so you're going to have to use TOF. So it's going to be on a case-by-case basis. I'm so sold on centroided for thermo data that I've actually been thinking about adding a warning when you choose Orbitrap or FTICR for some of these algorithms, certainly for DIA. So yeah, it's not, I'm sorry I can't give you a clear, like, yeah, there's just one right answer. It's going to depend on your instrument platform. But go ahead and, give us specific, like, here's my instrument. What should my settings be? Go ahead and post that to the support board and we can have that discussion. What settings can you change to be more restrictive in regards to peptides quantification? So again, you can narrow your target list. So that's the main thing. So if you want to be more restrictive and get better results, I mean, you could do we didn't do this in CelebSec. You could, so actually even more restrictive. So we're doing this experiment and we're doing refinement. And what we've come up with is we're saying maximum precursor only, CV above cutoff, doing equalized medians, detected in 4 replicates. So this is a whole refinement experiment. We could have also said, where is it? Minimum P, refine targets list based on importing results. Maximum. Yeah, we could have done maximum peptide rank. So to get even more, restrictive, we could have said, yeah, we actually only want to use the 3 most of all these other things, we're going to take the 3 most intense peptides for every protein, because we're only interested in protein quantification, and we don't need to quantify a protein with 10, 15 peptides. So that would be getting even more restrictive in our refinement phase. So we could have done that in this SelevSec reps thing. We could, and you could do it now, right? You could rerun it, and once you understand how to look at the data and decide whether you got better quantification, I think that would be an interesting experiment. There are a number of interesting experiments I'd like to run to see, what's better, what's worse, and unfortunately, I don't have a simple metric for that. But yeah, so there's definitely ways that you can get more and more restrictive, and I think reduce your noise. Certainly, if you're taking some set of the most intense peptides for each protein, that's going to be higher signal to noise and likely to give you better quantitative results. One thing that Lindsay also did is she ran a whole experiment, a different experiment, where she was able to assess the linearity of response. And so she might kick out things that don't have a linear response or that have an LOQ, so there are lots of ways that you can improve what you're doing quantitatively. What settings okay, that's the one that I just answered. Is there a maximum limit in size number of files that can be managed in Skyline with DIA, e.g. I'm working with sometimes hundreds of samples on the human DB or even bigger DB. There's not strictly a maximum. It's going to be based on the amount of memory you have. If you're, again, it's really going to be relative to the number of files and the number of targets, transitions. And so, we have people who've claimed they're doing over 1,000 in a single document with a targeted set. And so it doesn't matter how big the data is. If you target like 1,000 things, then you probably all 1,000 files. If you're saying, oh, I want, when you say a human DB or even bigger DB, if you're going to do hundreds of samples and you want to query 100,000 things, so that's going to be millions of transitions. I think probably that's not a good fit right now. That's gonna end up being too big. So, yep. But again, if you can do some prior experiments like we're talking about with SelevSec reps, where you do a small number of replicates and you do some assessment, and you say, oh, okay, here now I'm gonna, yeah, sure, I want to measure 10,000 proteins, but only with 3 peptides. If you can limit it somehow, you can still probably get hundreds for sure. How can we tell which IRT peptides were more close to our peptide of interest when parameter characteristics shall we look at? Closer retention time?
I'm not entirely sure what this person meant.
I don't understand that one. All right. We thought great, lots of great questions. Thanks for people hanging around. I think we're just gonna wrap up here. We're almost an hour over again.
Brandon, thank you so much for the session and for the Q&A and for the office hours after that. And thank you very much, Juan and Ali and Diana, for answering the questions. So tomorrow we have
we'll be back on May 11th.
Exactly. So tomorrow we have keynote by the great Lindsay and by Isa.
Oh yes, the great Lindsay.
And then we will have 3 days actually dedicated to R, 2 for beginners and 1 for intermediate and advanced. So if you are using R already, please come to listen to Kylie, because she has really useful insights on how to use R more effectively. And then indeed come back on May 11 for discussion of MS Stats with Mina and Brendan and myself. And so hopefully it will tie together all the discussion that we started so far.
All right. Thanks,
Thank you,
everybody.
Brendan, and
Thanks,
thank you,